Give it a minute, let it propagate through the internet and all of her tubes, the series of, until I see it over there. There it is. Okay, and now I can get YouTube chat in here with everybody else. This one goes away. And then auto find and activate. Bada bing, bada bingus. There we go. Okay. Whew, that does all that stuff. Sorry, I went on a little bit late, had a bathroom diversion, and then I'm just getting all my stuff together again after not streaming for like a week. Yeah, we're gonna do another coding stream today because I need to get this program together. I've been working on it in the background. I got a little bit done on it, but what I'd like to do is make it read the buttons, do a couple things like to build its own packet with the buttons, and then throw the packet out to the device. And maybe, just maybe, I can build in something so that when you hit the button, it will move on to the next number of packets. From what I saw, and this is from me just going around the internet, I actually saw that there was, somebody had like an air pump or something of that nature. Not an air pump, I think it was a water pump, just a water pump, a BMW water pump that spoke LIN bus. And the device's address was 26, so it's pretty far down on the list. Ours is 2, but the BMW water pump gave a bunch of statistics, temperature, flow rate, et cetera, et cetera, et cetera. Not like a measured flow rate, but like what its setting is at. In order to get it to go a different speed, you would send it a packet that's one address behind the current address. So it's possible that if we send 01 with a 2-byte package, literally just all Fs, or we could send it something, you know, a little bit more cromulent, like a random number, it might turn on the backlights of itself. What I'd like to do is take this readout, which is a 2-byte packet, and throw it back at this. Actually, I think it was 4, it's like 4, 8, and 16. No, it's 4, 2, 4, and 16, and then it's actually 17 because of the checksum, which is weird. But anyway, so send this thing a 1 address off packet, and then we get back, well, we potentially turn on the backlight. And there's only so many addresses to try, so if we run into trouble with it, if my initial test does not in fact turn on the backlight, then we can explore around and try to basically make a brute forcer for this thing. And it should get through it pretty quickly, given the throughput that we've got. And hopefully that gets this working and we can put this away. Because the end goal for this is to turn it into CAN bus, so that we can put these devices on the CAN bus system. And then, you know, obviously I can finish this one up, and then we'll have a bunch of CAN bus devices that we can then test with the Raspberry Pi. Obviously I'm getting distracted because I ordered this thing off of eBay and then it came in the mail, and then we went to hack it and we succeeded really quickly. We actually got this thing working really nicely. What's up, Wheezy Peasy? How you doing? You got the Immortal in here. I don't know, just Kiss. Should I just call him Kisa? You just Kisa. Yeah, we're just hanging out. I had a stream. I was a couple minutes late, but I'm on. I went on. I still didn't feel 100%, but I'm on. Yeah. Yesterday morning, no, morning before yesterday, Tuesday's stream day, I wake up and I'm like, oh, there's 2 dogs here. Hello, 2 dogs. I get my cup of coffee and I'm like, man, I'm feeling a little, after my morning routine, I'm feeling a little wheezy, like a little grumbly, a little queasy. So I grabbed a ginger candy in the hopes of like settling my stomach, and I ate it, and it was a really strong ginger candy. Should do a really good job settling the stomach. And then just that sudden warning sign coming, burbling up from below, and I had nothing in my stomach. I just threw up. What the hell's going on? And then I felt ridiculously tired, and I feel fine now. Got a haircut on Wednesday. No more mullet. No more giant mullet. Yeah, I don't know if it was a reaction to the ginger candy or if just the general stomach setup that was going on right there just was not having it. It was like, nope, no, sorry, nope, not gonna have it, not gonna do it, not gonna do it. Good times, good times. Yes, and I got my haircut yesterday. All of them at once. And the beard. The beard trim doesn't look as hot as it did yesterday. Usually, directly after the beard trim, all the scraggly stuff is gone, but I reduced it a little bit. It's still kind of scraggled, but yeah. The ginger is strong. Look, I had a bunch of those candies yesterday, and I was fine. I don't know what it was. It was like the wrong thing at the right time. Yesterday was exhausting. Yesterday and the day before, we had two corgis upstairs, and it's because our neighbors suddenly moving out. They sold their place, got a condo, and like straight away getting rid of a bunch of their stuff. It's pronounced Malay. Huh? Melee? What do we, huh? You beat me to the punch. I was in the middle of typing which one. Oh, which hair did he cut? It's like the classic. That's the joke, you know? I just say all of them. Got all of them cut. Every single one. But yeah, so we had two dogs here, and walking two corgis that are trained differently, because two different families, and, you know, the dog, you got to train the dog to walk. Some dogs, I guess, our dog, we need to be better about training her to walk, but they just go in completely different directions, and they're both like these little anchors. I missed the show Two Stupid Dogs. That was a good show. But they just walk in completely different directions, right? And so I'm trying to like rein them in, keep them from walking into traffic and all that stuff. They're not really trained to like walk in a... Well, okay, the boy dog is, ours doesn't. Willow does not like to walk like at the side of the road, along the road. She likes to kind of meander all over the place and just go all kinds of different directions. So it was not, I say Malay as if I'm French. I see. Yeah, no, I am demolited. I do that all the time, those kinds of pronunciation things, because my dad was a doctor, and so he was a psychiatrist, and so all of these medication names and condition names, and, you know, tinnitus is the actual thing. It's not tinnitus, because an itis is an inflammation, and tinnitus is not an inflammation. So that's the kind of stuff that I like traumatically know just because of my father. My father. Yeah. So, so when it comes to pronouncing like more complicated words, I kind of play around with it sometimes. So I've no doubt said Malay all the time. No doubt. And I understand. Dad is a psychiatrist. That explains a lot. Should put dial tone noise over that. Do do do. No, my favorite is what was that one? That was Lynn Jarvie? No, which one? No, it was not Lynn Jarvie. It was Moriza Rescompel. Which one was it? Oh damn, I don't remember the medication name, but the official name was like, it sounded like Snoop Dogg, basically. Resumkel. Skyrizzi, that's the one. Yeah, that is actually. Here, look at the so Skyrizzi. I heard one ad that called it by its official name. $52 matches for Riz on this page. Jesus. Where do they call it? Where's the... Oh, here. Rizan Kizmabriza. Rizan Kizumabriz. My Riza. What the... Like... Rizan Kizmabriza. Mabriza. Where is that? Add text. Wait, no, we should be in this one. Plus, where's text? Text. Risan Kizu Ma Briza. Risan Kizu Ma Briza. What are they doing with this? Did they know? Did they know? Did they know? Did they know that it just sounds like Risan Kizu Ma Briza? Boy, howdy. They're just making fun of us at this point. They really are making up words for medication, yeah. Kiss my Rizzler booty. Yes. Ridiculous. Ridiculous, Sky Rizzy. What are you doing? What are you doing? There was one ad where they actually said this out loud. It sounds like a slur. Yeah, it really does. I think we're out here inventing slurs, Sky Rizzy. I think maybe the industrial medical complex has gotten a little bit crazy with their namings of things, and they've started to kind of round the other end of some kind of a dial that I don't want anything to do with. I don't want nothing to do with that dial. That dial we're staying away from. We don't do that here. We don't do that here. Hand me my seltzer. I'm super white. It almost tastes like what's on the label. That would be too strong, though. This mix is just delivering and delivering and delivering and delivering. I'm sitting here like making jokes, trying to be funny, and in the background, my brain is like, hey, listen to this song. It's cool. It has synthesizer-y stuff going on, and you like it. You love it. I'm like, oh, yeah. I don't know what it is. I do feel more awake now that I've had my hairs cut away from my face. I don't know what that is. How do girls not be sleepy all the time? You know, am I right? Maybe it's just me because I have heavy hair. My hair is ridiculous. It's just too thick, too thick. Of course, everybody in the neighborhood is jealous of that. I'm like pretty young in the neighborhood. Everybody else is kind of old and bald and gray. At least the people that I run into walking dogs. Man, this thing has been cool though. I've actually been quite happy with this project, this facet of the project. I know there's a whole ass setup that I need to get back to. That's like the focal point of the entire thing is that I'm building this giant simulation rig, pretty much like against all sense. I really shouldn't be doing this, you know. This is like a big thing, and if I end up having to like move or something, I won't have space for it. I'll have to make it be the entire... Why would I be sleepy? Listen, I had long hair and I was very sleepy, and then I got all of my hair cut, including my beard. I cut my beard myself, which is why it sucks. And now I feel more awake. I don't know. And that correlation has happened a couple times. You hurt the beard. Why did you hurt the beard? The beard did not get hurt. The beard is in perfect shape. I had to linish back the scraggle because it scraggles as it grows. This gets a little bit longer every time, but only by a small fraction because I need to keep it thick. It needs to be thick enough because like it's not thick enough here. This is the bad part of the beard. And then this is a little better, but yeah. That, yeah, getting ready for spring gets me a little bit, my head's a little cooler. I don't have all the mullet stuff going on. Since it's already big, why not add a Stewart platform to the project? I'm not made out of money. I know there's like this magical place that all these YouTubers like summon their money from. I don't know where that is unless I partner up with like an industrial provider, or if I had enough viewers for people to actually like get influenced by me. But like platforms and stuff, that's getting into the thousands of dollars, like tens of thousands of dollars. Might as well just buy a car. I'm afraid of messing up the beard trim, so I just let it go homeless style. You gotta linish it back a little bit though. It makes it much neater. Mossad funding. I hate it when my bangs get too long and stab me in the peepers. That was happening to me. If I didn't wear glasses, that shit would be whipping into my eyes. Djibouti Show was playing a GTA-like yesterday, and it was one of the funniest friggin' games ever because it was so violent. No guns, everybody was fist fighting, and probably very big medical bills. I was saying during it that that game needs a Burnout-style dollar assignment of injuries that you're causing to people. It should be like boom, broke a bone, $10,000. Like you should be trying to go for the most medically brutal and debilitating cost-wise score. But that guy had hair that was down at eye level, and I was like, how does that guy move around? I have to have the glasses. They're like safety glasses for when my hair's whipping about. Only beard I have is a tiny peach fudge and a single chin whisker. Yeah, but like when I was framed in my own hair, it was like I was just kind of sleepy all the time. I don't know what did it. Whenever I get a haircut like this, I feel like fresh the next couple days. One thing I do have to look into is my iron level. I'll have to take a look at that. I may have to go do the blood thing again. It's photosynthesis. Maybe it is. Am I photosynthesis? Maybe it's all the vitamin C that I'm making with the extra skin exposure. You can have some of mine. I got enough beard for 5 people. I did try to grow the beard in college, but it wasn't until a bunch of years ago I was fired, and then I was like, well, okay, I'm not going to be doing anything for a little bit, so let's grow the beard. It took me a little bit of time. You back? You're on there? Okay. Blocked or being censored. I haven't done anything. That ain't me. We haven't blocked or censored anything but a bot in a long time. It's funny, the toxicity, I think, has gone down on the Twitch platform. I think as people have moved away from Twitch and are getting like real lives, maybe there's a lot less. I said pretty boy. Well, maybe YouTube was sparing me that. Too early to transition to get that full beard effect. Well, maybe it'll happen eventually. I don't know. Some people all the way into their old age cannot grow beards. I decided to try and see what I get, and it turned out to be pretty glorious. But I know a couple people out there were mourning my jawline, because apparently I had a decent jawline. I probably don't have a good jawline right now because I'm, overweight. But I'm fixing that. I'm fixing that a few pounds per month at a time, as long as I can keep progress on that going. Because the first thing I did after seeing the second weigh-in, because the first weigh-in was from hospital scales saying that I lost 3 pounds. And I was like, that's interesting. And so a month later, I measured myself again and I lost another 3 pounds. And I went, wow, this is great progress. And then the next day I ate a whole cheeseburger and fries. So, so I don't know if my positive progress is going to be maintained, but in a month, a little less than a month, I will weigh myself again. And if I'm not down 3 pounds, then enter the hair shirt and I will stop eating food. I've been on the Ozempic, so it's like I can feel satiated with much less food, and that's having a whole cascade effect on a whole bunch of different mechanisms that make it difficult to lose weight. The calorie in, calorie out people are correct, but on like a physics scale, and it's not on a this is how you lose weight. You can literally sit there and militantly count calories, but there's a lot of mechanisms that sort of make losing weight very difficult for people who are overweight. And it's not acknowledged a lot of the time because you get survivor's bias from people who go, wow, I just ate a lemon and now I lost 60 pounds. And everybody goes, eat lemons, eat lemons, eat lemons. And it's not how any of this works. And I'm trying to do it healthy. Yeah, and the thing is, like, I could become, oh, this one isn't calibrated. Hold on. Set up. Micro procedure. Like, the thing is, like, if you're not moving, you can become like a popsicle, basically, shape. And that's somewhat happening to me, but I am getting out and walking the dog and stuff. So I got to watch vitamins too. As a fellow overweight person, facts. Yeah, look, The people think that Ozempic is cheating, and those people like should probably be smacked in the mouth because what it does is fix mechanisms that were sort of stacked against us in order to facilitate healthy weight. So, yeah, and leave it to the person with an autoimmune disorder to have weird hormones, right? If I could get back on testosterone, I would probably be losing weight in a more graceful manner because I'd be able to build muscle on top of all that. I can still build muscle. I'm sort of borderline low testosterone, but they will not let me back on it until my blood work looks okay. And then they might, but I don't know when that's going to happen because they discovered I have a high amount of iron in my blood. I have too much iron in my blood, and so they have to do literal bloodletting in order to get that back. So yeah, it's like all this bullshit all at once. Why do you have to watch vitamins? Apparently on the GLPs, you lose, what is it? You need to supplement vitamin like E or something like that. I forget which one it is, but one of them sort of falls out, and you also have to like actually should work out, which I'm not quite doing. Walking the dog close, it's something, but like I'm gonna lose a lot of muscle mass. I got big muscles. I got big muscles because I'm a big boy, and I hope to keep them and lose the stomach. but I haven't seen anything happening in the stomach land. But it might be slow enough that I don't notice. I don't know. We'll see. Iron overload, yeah. It's the doctor describes it as like rusting your insides, and I'm like, ugh, is everything that I own is full of rust, huh? So I've had to have them take a pint of blood, like 500 milligrams of blood at a time. Yep, hematochromatosis. I have one of the genetic markers, not both. I need iron. Give me some. send you a bag of blood. The last couple times that they did it, they used this giant insulin bottle looking thing. That was just it was a vacuum chamber. I have a horror story from that, and I don't really want to tell it again because my arm is still a little bit sore in that spot. Basically, the jar was allowed to come up to atmospheric pressure, and then my heart pressurized it beyond that, and then they plugged it in a way that air shot into my arm, and then I felt my vein up here go, and then my lungs hurt for a little bit, and then that was it, because the lungs will filter out air in the system. Yeah, that was a tough day, and they only just apologized, and I'm like, that's it? You almost killed me, and that's it? Love hospitals, love them. Ozempic, semaglutide, primarily depletes vitamin B12. It's vitamin B12. Vitamin D, I already take supplements of. It depletes iron? Oh, perfect. Maybe I am in balance. And magnesium. I'll go eat some magnesium. Due to reduced food intake. Okay. And slower digestion, it can also lead to deficiencies in calcium, zinc, and potassium. I need potassium. Get the banana. Not the flappy vein. Yeah. Being iron deficient sucks. Yeah, I imagine. For me, it's just every single thing that I've got going on medically causes fatigue. So I'm just, why am I always tired? I thought that was just what being an adult was like. When I was on testosterone, though, man, go to bed early, wake up early. Yeah, let's kill it. Let's go to the gym. Let's lift things. And then I was working with like resistors or something, and I dropped one on the floor, and I went, and I'm like, apparently, I'm like, why am I so mad? I just dropped the resistor. That was my fault. I really shouldn't be getting so emotional and angry, like just dead angry at a resistor. I'm like, oh, that's the aggression that testosterone brings with it. But man, for a little bit I was on that stuff, and it fixed me. And then I got fired from a job, and that was a different job, but I got fired from it, and there was a bit of stress involved in that, and I stopped taking it. Blah, 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 blah. Yeah. BS. I was on super iron deficient. Hemoglobin was supposed to be like 13 to 15, but you were at 5? What is that like? Just keep the salt like in the corner of the room. I had a little wound vacuum that looked like an accordion running to my neck. Oh yeah, that's like post-surgery. They do that for the fluids. I had one of those too when I got the cysts removed. I had one of those salivary gland things. That was a while ago. Yeah, those are kind of creepy. Those little baubles. But if you have like a deeper surgery, it helps massively, apparently. Could not walk with low iron. Could not walk a few steps without running out of breath. That's crazy. Crazy, crazy. I think we actually ran out of this mix finally, so we can actually get to like working on this thing. I have been champing at the bit. By the way, it's champing at the bit. It's not biting at the champ. What is it? Chomping. It's not chomping at the bit. You don't chomp a bit. A bit goes behind the teeth of the horse. They can chomp on stuff regardless, but they just have a thing behind their chompers because the horse teeth are all in front and then there's like a gap. So you champ at the bit because you're pulling at the bit. Pulling, I don't know, champing, but whatever. Hi, welcome to Grammatic and Linguistic Pedantry, the stream. This would be where I'd put in a cheering crowd sound. I don't have all of my morning zoo sound effects I generally don't do those, but I should. I probably should have something else in the soundscape to, you know, highlight the jokes and stuff like that. I have the mixer that does that. I have a couple things that I want to record onto it, but I don't have it local to me, so I can't do that yet. When I do the games, you guys remember games? Do you remember games? I used to play games on this stream. We'll get back to that. We will. Too much work to do. But when we do get back to it, I'll have my morning zoo sound effects that I'll be able to do. So I always wondered if it hurt the horsey. No, it really shouldn't. I mean, you think about like how horses act, aside from being like a completely suicidal animal, they basically are scared of everything. And if anything causes them discomfort, they run or blow everything up around them and then injure themselves mortally. So you would think that horses are quite comfortable with the champ on them because they don't put up a single ounce of protest for it. And if they see a bug that they don't like, they will rear up and start kicking. So it's one of those things. It's like, well, if that sets it off, then this doesn't. It's probably fine. I can't speak for the horses though. I'm not even sure they exist. But yeah. Anyway, everybody's working on stuff. I'm working on stuff. I got sick on Tuesday. I don't know what the hell happened, but I'm good now. I feel like I'm okay now. I'm still a little bit like tired, but I got a haircut. I got a haircut, everybody. Oh my God, I finally did it. I reared up all of the introverted power that I had, and I didn't pick up a phone. I actually went on the website and scheduled a haircut. But that got me out of the house, and I went to the haircut place, and I went, I haven't seen the outside in a while. And then they cut all of my hair off. So now I can do this without hurting myself. I don't cause mortal injury from hairs whipping into my eyes. Somehow, getting my haircut made me less sleepy. I don't understand where that one comes from. I'll be like down on everything, and I'll be like a little depressed and like tired. And then I'll get my haircut and it's like, the sun's come up. I'm like, I feel much better after that. I don't know what it is. Maybe it's just the weight of my own personal hair. The weight of all of my actions. The regret. Anyway, so got the haircut. I didn't get a damn thing done. Plant-like behavior. Honestly, it might be tied to vitamin D. Maybe that's what it is. The sun on my back, giving me all that delicious vitamin D as a mood-altering substance. The social interaction gave you energy. Let me tell you something about streamers. Getting a haircut is like now obviously streamers saying, I had to go outside today. It was the worst thing ever. Take that with a grain of salt, because these are people that live in their basements. I mean, we're all like tubby basement dwellers. Us streamers, I'm turning the gun on myself and my colleagues in saying that the stuff that we complain about is like the most milquetoast stuff in the world. Say, oh man, I had to move a plant today. Like, these aren't problems. These are things normal people do. But the haircut is like the mini boss that's harder than the boss of introversion and streaming, because you sit on that chair and they go, so what do you do? what's your identity as a job holder in the modern economy? What do you do for society? What is it? What do you do? What is your living? What do you make money off of? What's your whole personality assigned to you by society from a job? And I'm like, I'm not going to explain to you what streaming is. It's the most awkward thing I could possibly say to somebody who's cutting my hair and have them not understand. So I do like engineering. It's like a lot of spreadsheets, a lot of meetings. And they're like, oh, okay. And then instantly it's so boring that they will not ask any more questions about it. And you go, I mowed the lawn the other day. It was really, I was sneezing. Like, it's just stupid small talk. Oh, I hate it. It's not that I hate small talk, because you can't always talk about like the morality of modern society, but just the little absent small talk that you have to make with getting a haircut. I should probably watch like sport at some point, and then I'd have more stuff to talk about that isn't like, hey, did you see what happened to like video game? No, that's not, you don't talk about that with normal people. Anyway, I'm feeling pretty good. We've got some Arduino programming to do. What my plan is, as if there was a plan. I mean, I want to get back to working on the big boy over there, because there's a lot of big things, a lot of like physical things that I need to sort out on this driving setup. It's gotten a little bit out of hand. I mean, that's just how these things go. Not sport, anything but sport. Get a hair comb and leave it in the hair as they do. What? Well, like a little loot box for them to find in my hair. So we have a bunch of stuff to work on. I've been using real car parts to make a car simulator, as well as all of my other like sim stuff that I've collected from friends who had kids and decided they don't want to have a Thrustmaster joystick anymore, which still doesn't make sense to me, but I guess people downsize and stuff. So I've ended up with like a lot of kind of cool stuff to do all of these sim games. And I keep saying sim. There's some other games that'll do joysticks and stuff too. So there's a lot of fun to be had out there. I appreciate the building part, and especially appreciate the hacking part. And the hacking part comes from the fact that cars are not as they used to be. I know everybody's not me, and so everyone's experience, even as like people who work on cars, is so much different than it used to be. But it used to be we would hack into our cars by pulling them apart and adding stuff to them. In the sense of the way cars have gone, basically, instead of having 4 wires that carried the different speeds of your windshield wipers, you have one wire that speaks digitally to a bunch of things. So everything has topology, everything has communications protocols, everything has signals, and those signals they typically don't like to publish. The Lin Consortium said, hey, we could have a lot of like really cool stuff in cars, a lot of like buttony stuff that runs off of a slightly slower digital system. And so your button can talk to a bunch of stuff at once, and then maybe something can coordinate what the car does in response to that button, right? That's sort of how cars work now. The Lin Consortium came along and said, hey, what if we standardize this a little bit? So we have like a data broker thing. I don't know why. I guess they all decided to work on it together so that they could come up with something that works like cheaply, because they're all working together. I guess that's probably what it was. They didn't want to all hire different engineering departments to come up with different systems. They made one system. It's not like, I don't think they would support using like cross-platform parts in cars. Like, hey, this is a switch from a Mitsubishi, I'm putting it into my VW. But I guess they kind of can. So they made this wonderful system of digitally communicating between modules, right? Everything speaks the same timings. But they left it up to the car companies to figure out what types of signals things respond to, what types of things they say or don't say, what information they're communicating out. And as such, being car companies, they decided to keep all of that information, all of those different signals and stuff, close to the chest. They kept it close, and they kept it behind paywalls. So there's probably some kind of a system that we could pay a couple $1,000s for, and then we would have all of that deep level sort of engineering information. Generally, to work on a car from a manufacturer, you don't need to know all that. You can just hit the CAN bus with a couple diagnostics, and then the CAN bus tells you, yeah, the Lin bus is doing fine. But it doesn't let you see behind the curtain. And there are some tools that you can get that will directly look at the Lin bus, depending on what car you have. But again, I can't just look this stuff up. So we have to hack into these signals. We have to hack into these systems. We have to send it just a bunch of messages and see what it responds with. Now, for the most part, because the LIN bus is so small, it is not that hard to do things like brute force. If you have a device that's replying to you, as long as you stay out of the diagnostic addresses, you can ping every address on the system in about a second or two. So if we ping it, eventually somebody responds to us. And so we found out, and this is stuff we did on the steering wheel years ago, we found out that it will reply, and that reply contains all the information that we need. But they were deceived, for there was another address that we did not get to. These both of these automotive devices are backlit. These have LEDs in them. And for the most part, we have absolutely no clue how to get these LEDs to light up. This thing, in spite of the fact that this is in fact in control of the lighting of the car, does not give us a periodic backlight strength signal. If we change the headlight status, this is asleep, it'll try to wake up the bus. We've seen it do that. But in no way have we been able to send these things commands and have them do stuff. So I got to looking around on the internet. I was looking far and wide during the time when we weren't streaming, and I missed that one. If it's steer-by-wire, they don't much do steer-by-wire these days, although we're getting close. There has to be, I thought, maybe I'm wrong about this, I thought there has to be a physical connection between the driver and the steering rack. All of the electric systems are like an assist. They give you more power as you move the wheel, but you always have that direct connection because that's a safety thing. Same thing with why you have an e-brake that has like a physical connection to a brake. That one I don't see so much in the cars nowadays. I've been driving my mother's car a little bit over the past couple days, and that thing is weird. It's got all these little assist systems, and then you have to dive into menus to like adjust them. The Tesla dumpster might be. The regular Teslas are actually, the thing about like the Teslas and how ubiquitous and cheap they are, is that they have all these really cool systems that actually benefit the internal combustion people. Like that electric rack on the Tesla and the electric brake assist are really good to have when you have an unreliable motor in your car. And if the internal combustion engine goes out, you lose vacuum. So the vacuum assist, well, cheap and easy, versus an electric assist, you still have an assist when the vacuum goes out, which is kind of nice in some systems. Yeah, throttle by wire. I was active during the transition, and a lot of the car guys did not take it well. They said, "How the hell this doesn't respond fast enough to my input?" And I'm like, "Bitch, you don't even know. Like, it'll respond faster than your input. Those throttle by wire is totally fine. It responds immediately." Everybody thought you had to have a cable, and meanwhile, I'm in a car where if I blip the throttle, my cable's going to fall out, and then I have to pull over to the side of the road and put the thing back onto the throttle body. Very annoying. My 98 RT rolled in a lake. Oh. Okay, anyway, so the thing is, we're hacking car parts, right? And there's very little information about what individual signals exist between manufacturers and stuff like that. LINBus 2.0 says, hey, you guys can reassign all the module numbers if you want. We discovered that our headlight switch is number 2 in decimal. The thing is, it's a hexadecimal number, so it's 0 to F. Hold on, I gotta burp. Okay, it was just a little hiccup. 0 to F, right? Those are all the assignable positions. And then there's a decimal equivalent of that, which is 0 to, what is it, 14 or something, that we can represent in 4 binary bits. The number counting is all a big mess. 0, 0 is typically not assigned. 0, 1 didn't do anything. 0, 2 got us a packet that describes the position of everything on this, including this guy and these guys. This one is represented by a slightly larger number, but these are just 1s and 0s in positions. So we've got something that we can actually use. Imagine using a Stream Deck for buttons. I mean, you could do that. That's what the Slate truck is like, an electric vehicle that I'm sort of like, Because like you can get supposedly, the car hasn't released yet, you can get an entire slate truck for the cost of like a down payment on a Rivian. It's a cheap electric car, and you can put your tablet, your own tablet, whatever, or your phone as sort of the display. And so I have one of those little tablet portable computer things. I don't really know if I should have bought. I haven't done much with it, but if I could connect that to the truck and that would be the primary display, that'd be good use of the thing. That'd be kind of cool. Elgato project, not a, oh. Yeah, you could probably also use a Stream Deck, not a Steam Deck. Sorry, I read the wrong thing. I thought you said Steam Deck, but Stream Deck. Yeah, I don't, you know, if you had a, like an in-between, like a Raspberry Pi that would run this, you could maybe get this thing to speak Linbus. I don't know though. Anyway, point is, we don't have the information we want. I did a little bit of spelunking on the internet. I'm getting very distracted by chat because chat's like healthy and chatting for once, and it's great. It's actually really great to see. I love you guys. Anyway, so we've been hacking into this thing, and we figured out how to get information out of it. We now need to get information into it and get it to turn on that backlight. The example that I saw was pretty cool, actually. What's that? You could probably use a Steam Deck to install AGL. Is that what these like robotics people are? I saw like for the Super Bowl, the Superb Owl for the Super Bowl, they had this camera rig that was a fully like robotic camera rig, and the operator had a Steam Deck, not a stream, a Steam Deck. And they were like, they had their video feed and they were able to control all the different robot stuff. Oh, that's automotive grade Linux, AGL. I see. That'd be kind of cool. So anyway, we got to get this thing to do something. I did like spelunking around the internet, and I found that somebody had a BMW water pump, an electric water pump. I don't know anything sort of beyond that. I'm not sure what even it was. There was a nice little GitHub page about it. And apparently that water pump spoke Linbus. And so if you poll one address, it would give you back information about how the pump was running. It would give you water temperature, what speed it's supposed to be running at. There were a couple other things that it had in there that were like information pieces. Very cool. If you send it the address before and you add 2 bytes onto the end with a checksum, it would change the pump speed. So my thoughts on that are probably these things might be very similar. If your water pump has a microcontroller in it, you're doing something very wrong. Not necessarily. Come on now. Motors are more complicated than that these days. You got 3-phase motors and stuff. They're powerful and small and compact, but then how do you get them to go a certain speed? You need a motor controller, and so that motor controller needs to be able to look at the fluxes on the motor in order to control it properly and make it move really nicely and efficiently. And so you need a microcontroller. The worst thing ever was for like an NXP semiconductor chip that was like one of these honking great massive bastards. The big chip with like 10,000 pins. It was like, you could use this in a hand drill. And I'm like, what? Why would I want like a 70 megahertz processor in my hand drill? Well, it turns out all the hand drills are going to 3-phase motors. They're going to brushless. Without those brushes there, your motor lasts a lot longer. Your drill gets more compacted. It uses its energy much more efficiently. But in order to do that, you need to give it a tiny little brain. And so they're giving them very powerful, tiny little brains that can also do things like current management and charge control and all that stuff into one thing. So, you know, motors are getting more complicated, and so this motor has a microcontroller. I think that's fine. But I'm a nerd, so whatever. But anyway, this water pump has a microcontroller in it. It responds to the address that's directly next to the one that it responds to. So it listens to one, responds to the next one. If that's true there's a chance that it's true in this, there's a chance that it's true in this, and if we just carte blanche, we just send it that byte packet on that address and we get the checksum right, we're good to go. First task, we need to make sure that our checksum is being calculated properly. I know this stuff is over everybody's heads. I'm going through it, and the best of my ability is like a book report almost, that I'd get like a C in. But hopefully all the information that I'm rolling out is factual and correct. I don't expect anybody else to be on the same page with me. We've done a lot of stuff with the Linbus, and it's complicated. It's hard to get everybody up to speed, but hopefully this whole explanation has brought you there. I've been a little bit discombobulated, obviously. It's not, it's not a TED Talk. Oh, one of the things that drove me to go get a haircut was Guar did like a TED adjacent talk. The lead singer, as of 2014, the lead singer was the original lead singer of Guar. They took a back seat for a little while. Then the lead singer died, and then this guy came back to reprise his role. And Guar did like a little TED talk, right? And he looked like me, but like wearing black, and I don't usually wear all black. But he had the thick top hair with the ponytail, and then the big scraggly beard. And I was like, I should go to the barber. I'm not the front man of a heavy metal band. I should go to a barber. When Jensen jacket. I don't know what that is. Jensen jacket. Yeah, Guar, like that Guar. Yeah, like Guar gum. Or ROG if you are not a large enough venue. I never knew what Guar was about until I saw like them in a more modern context, and the TED talk was really cool. It's just about like making art and, you know, all that stuff. This is cool stuff. This is what the frame, quote unquote frame, looks like of a LIN-bus packet. Oh, the Jensen known for his leather jackets. I see. So this, those tech guys, they always want to wear the sport coat with the graphic tee underneath. So they look kind of like, oh, I'm not that uptight, I'm kind of cool. It's so dumb. Anyway, the frame. It's called a frame, not a packet. It's a frame, and the frame is two-way communication, typically. Two-way communication between the bus master and the thing that it's controlling, between the DOM and the sub. So the DOM will send out this header, and the sub will send a response. So in this case, it says, you've been a bad girl. Here's the brake feed. Here's the sync feed. Now respond to me if you are this address, you naughty, naughty boy. And then the response has a little bit of a delay there. This is the amount of time that the microcontroller gets to do the things that it wants to do, right? It goes, oh, 1 sec, I just need to put on some shoes and figure out what the packet's gonna look like. And then it has to respond to all of the data, or with all of the data, and a checksum. And the checksum in LIN-bus 2.0 includes the protected identifier field, which is kind of confusing. So that's part of the checksum. The checksum is done in a particular kind of mathy way that they describe in these documents. And so I've implemented it personally. Apparently they have C code for all this stuff somewhere. It's like in the appendix. I didn't use that C code. I'm just making this up as I go. So most of the time this is like bit banging all of our addresses and stuff. I miss Guar. They threw a hell of a show back in the day. I saw them when they were in Philly like 10 years ago. And it was a decent show. It was a good show. I think it was 10 years ago, but apparently they're out of Roanoke, Virginia. Okay. So we have this frame and we know what it contains. Our frame that we're sending is just going to be data 1, data 2, and then checksum, right? And we don't know if data 1 or data 2 is the thing that it's going to respond to. We just don't know. All I have is an inkling of an idea. If another BMW device worked in this manner, maybe this one does. So the Hail Mary is going to be just sending the packet normally. We can also make something that will send a bunch of different packets, but in our case, I just want to see something happen. Yeah, you gotta flip it up a little bit. So yeah, we gotta put all that stuff together and we gotta give it a try. So I started in on the Arduino programming, and I have the original brute forcer that we got to work, but kind of by the string of our teeth, the skin of our teeth, not the string. Does teeth have string? By the skin of our teeth, we got that thing running. It's basically like a clapped out program that has just been doing too much. I took pieces of my main steering wheel setup and I put them into, I'm too old for Guar nowadays. Guar they've been around since the 80s, man. They're old too. We took an old program that was the master program for the steering wheel. It's something that I had run off of a Teensy 2, 3, and it basically spoke to all of the other devices on the bus, which was just this. But we also made the pedals and the shifter speak LIN-bus as well. We put everything on LIN-bus, and we had a whole happy system doing its, chooching along, doing what it needs to do. But now I want to move this stuff to a new program that's not as extensive, We have all the pieces, all the packet generation of the previous ones. So I pulled all that stuff into a new program, and it made just a complete mess of things. So I've spent a little bit of time reorganizing it, basically starting a new program and then pulling stuff over into it. I have this routine right here. This is to generate a Lin 2.0 checksum. The thing about the Lin checksum is you kind of go through it and you add stuff to a variable. They kept it uint8t, which is just a basic 8-bit thing. The byte, whatever. Is there a summary of your development to read somewhere? I should write something down. I should, but there is not. No, I just have little plans. We're just basically like looking at the feet in front of us, taking one step at a time. We got to take baby steps on this thing, because otherwise this whole entire system is crazy. I do not get what you are trying to do. This is a headlight switch from a BMW. Somebody out there does not know how to turn on their headlights. This is a simulator setup with a real car seat that I'm building. This is a real steering wheel from a Mercedes. That old guy's gonna be pissed he doesn't have a steering wheel. These all have digital buttons on them, and I'm trying to get to the digital buttons, but at the end of the day, I may sit in this thing in the dark, and I want these to light up, because these are all able to light up. And so we are trying to get these things to light up. And so I've plugged in a LinBus UART, which is a thing that changes the voltages around, because LinBus is a 12-volt system and everybody's speaking 12 volts. So we've plugged an RP2040, a Waveshare Seed Studio Zhao knockoff. It was like a $2 microcontroller. Pretty nice, actually. $2 for this thing, man. That's $1 for the chip and then $1 for the board. Cool stuff. So anyway, we plugged this thing into this Lin interprety thingy. And since we've done a lot of work in this before to hack it, we sort of know what we're doing. And I was able to use my old programs in order to hack into the light switch. And we found out if we pull LinBus address 202 with all of its appropriate accoutrement, including parity bits and things like that, this thing actually will respond. Your elemental power is green. You know, it's if we were doing like a microcontroller takeover, if I was actually going into these things and replacing the microcontrollers with my own, it'd be a bunch of these guys, just because there's plenty of room to throw it in here and just take over the switch panel. I probably would want to replace those LEDs with WS2812s. They've got little 2mm WS2812s. So if I threw those in here and gave them a bus, I could have RGB backlighting, but we're not doing that. I'm gonna leave what's in there. So, yeah, this is the backlighting amount. So when you turn on your headlights, the headlights turn on. Sometimes I shock myself with how amazing the things I say are. Anyway, so you turn on the headlights, and the headlights in the front of the car turn on, but then also all of the backlights in the car turn on too, so you can see all the buttons in the dark. This controls their intensity. So if you're on a long car trip and you don't want to be bedazzled by your own backlighting, you turn that thing all the way down and it gets nice and dim. So this control exists. I want to use it, especially if we've got all these real car parts that have backlights. Do you use Python for that? No, we're using Arduino. Listen, man, when did that happen? I used to get on stream at like 2016, and I used to say, hey, my generation, you guys are dumb. Stop calling yourselves old. We're like in our 30s. We're not old. I've reached 40, and it has passed years ago. So I'm old. I like programming my Arduino in the original Klingon. No, I like programming my Arduino in the original C++. We kind of call it C++ because it's not quite C++ and it's not quite C. It's somewhere in between. It has a lot of like water wings kind of things in it to like help you do like bit math and stuff like that. It's like a lot of this stuff has been swept under the carpet. And the reason that I love Arduino the way that I do, back in my day, back when I was like whippersnappers, back in my day, we had like the basic stamp, and the basic stamp spoke basic. You say basic as loud as you can because it's all in caps. Basic. No, not C sharp. It's not C sharp. Basic is very rudimentary, very microcontrollery still. There were still a lot of things that you had to set up before you actually got into the physical computing side of things. Arduino came along and they said, why don't we put all that stuff on USB? Why don't we not have a $300 programmer? Why don't we just put all of these setup flags behind the scenes, and you can override it if you want, but we're going to put it all behind the scenes so that you can literally type out a program in the way that microcontrollers work, hit program, and then your LED starts flashing, right? The important part about that is that you did not have to be a computer engineer. You did not have to be an electrical engineer to get something like that running. You could just go to a tutorial and you could just get a couple parts from Radio Shack, throw it onto a board, boom, your LED's blinking. Within 1 hour of trying Arduino for the first time, I had an accelerometer plugged in where I could tilt the breadboard and one of 4 LEDs would light up depending on which one was further, more vertical, right? I was just using gravity. But still, I did that in an hour. Whereas before I dabbled with other microcontrollers, I didn't get anything done. I didn't like do anything with them. It got too complicated and I said, well, maybe I'll try again later. Arduino, boom, 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 gets you right to it. And so people who are dumb and like artists and stuff can actually get to the physical computing part of this, and it sort of builds something. It sort of gets you excited about it, right? So that's where I learned, that's where I cut my teeth, and that's what we've been using for all the projects that I do. I like coding in Arduino. Now, Python is good. Python will teach you some habits that kind of can get in the way later on. Python gives you a very sort of, the way you think about a program running translates directly into the language on the page. And that's really good. Like when I was really going with Python, I was just like snapping out program, like bop, 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 bop. But this is what I know. I know my microcontrollers and I know my Arduino and I know how to make it function and be like good and all that stuff. So now there are still some cobwebs. I'm still not totally up to speed. Like when we really get into the coding, I'll be pretty proficient at it. But in this case, it's taken a little bit. It's been a little while since I've done like major coding, so bear with me. But we're getting back into some of these really microcontrollery car stuff. Do you have an idea how we can use Python in automotive? Python is typically a little bit slower unless you're doing like MicroPython. I think MicroPython is snappy enough, but Python in general, it's really good to like play around with and get your ideas onto a paper. But at least in the iterations that we've used, it can be a little slower. And I don't know if that translates well into automotive, but I mean, you can put anything on anything, right? These days, you can run Doom on a pregnancy test. Like the sky's the limit. You could definitely do automotive Python programming, but yeah, anyway, so we're doing the Arduino C++, and that gives me a bunch of like silly little functions for bit stuff, because generally in microcontrollers, when you're doing bit stuff, you're shifting around binary, and the shifting around binary commands and the way that they function can be kind of weird, and so you have to like iterate through and be like, oh, it's actually handling this out of order and stuff. You'll be back up on that bicycle in no time, hopefully. Yeah, and even between streams, I didn't get that much time to program, but this is the way that I generally organize my programs. I put all of my settings at the top up front. So all of your like other programs that you're pulling in, then you define all your stuff. You keep the pin out up top so that if you swap pins on the microcontroller, you can switch them very quickly. I put all of my timing settings because we're doing what's called bit banging, which is where we don't leave it to like a background task. We actually take direct control over this, because all this thing does is speak serial. So we want to take direct control of that serial speaking. Then I have all my variables that I use throughout the program, all the global variables. Setup is what runs once, and it sets up your pins and stuff. So we do pin modes and digital writes. If it gets any more complicated than this, I will sometimes put the setup stuff behind functions. Like if we have something that's sort of like a special trigger for something, or like a status kind of thing, this does tend to get more complicated. But over here we have the loop, and the loop is just executed over and over again. A healthy loop in a microcontroller program should look like an explanation of what's going on. It should be a bunch of functions that simply describe the different things that your microcontroller is going to be doing during its life. In other microcontrollers, I get kind of confused because sometimes there's just like a native while one sitting out in the open. They do things in kind of a weird way. Too good to know you're over there playing with your hair when you're not streaming. Hey. Listen, it was a monumental thing for me to get over myself and go get a freaking haircut and not look like a Sam Squanch. So I'm un-Sam Squanched and my head's a little clearer. At least I wasn't playing with myself. Okay, anyway, so these can be very simple. I like to have it so that if future me goes through my program, they can look at it and go, what the hell is this? And actually know what's going on. So I did read the switch, make the packet, send the packet, print serial prints, delay. So that's essentially what we're going to be doing. We read the status of the switch, we're going to make the packet, send the packet. The thing about making the packet is we have to rely on something that I don't know if it works, right? So we've got to take baby steps towards all of these different functions working. The first thing that I want to do once I get, because these are looking kind of bare, the first thing I want to do is make a packet. Well, actually, no, here's what we want to do. I want to read from the buttons so that I get a packet, right? Read from the buttons, I get the packet. Then I want to calculate my own checksum and send that over serial. So I'll have, here's the checksum that we got, here's the checksum that we calculated. That way I know if I'm calculating the checksum properly. Right, and we'll see it iterate over multiple varying checksums. So that's what I'm setting up right now. So make packet. Okay, so we're going to get this, put that down there, and we're going to do checksum test. Use button packet to calc our own checksum, poop it into serial. So what we need to do is we need to call the address, and then I need to load those bits in. Call address byte addy, send the break, delay, send the 55, because remember we're sending a frame. So this is what we're iterating through right now. Can we take a moment to acknowledge how freaking cool the concept of a checksum is? I want to take a moment to acknowledge how many things just flat out ignore checksums. They just don't care. They don't care about checksums. I've run into products that do this. They just don't care. I said, this is where the checksum goes. We don't care. I think the steering wheel doesn't care what the check. No, wait, the steering wheel does. Our stuff that we programmed didn't care. And I've seen other programs do that too, where they're like, we just don't care. Checksum is an interesting concept. In a noisy system, the checksum can really save your bacon because you'll have interference on the line and nobody gets it until you do that checksum calculation and say, hey, wait a minute. These are things that we're going to have to do anyway, is calculate our own checksum if I want to implement that in our system. I didn't, and we never ran into packet issues, so I never ran into packet issues. So yeah, anyway, we send the 55, delay, then we send the address. Then we put a little blip on the scope. On a pin that we're not using, I basically set it high and then low, and that way our scope can zero in on that spot, and I have a better display of what's going on. These are some of the things that we do in order to have a nice stream instead of something that I would do if I was actually engineering this. So like if I was building this for like my boss, I probably wouldn't have that little blip in there. But because you guys are my boss, I need to make it visually interesting, so. Okay, so that's how we do that, and now we're just floating out in space, and we're just waiting for the next thing to happen. So, first of all, frame start, get data back. And I guess, what are we doing with this data? Are we getting it and then we buffer it and then we figure out what to do with it? That might be the way we do it. Because if get data back would also check some. So I already have a routine for doing this. Bit start. Timer check. That's using the timer thing that I had. So I don't know if we can use that. Well, what is timer start my thing? Hold on, timer start. It's only in here once. Oh yeah, because I didn't move it over. This is how we were checking against the timer to see if we like missed that little response space here. But I'm not using that routine, the timering routine, because I don't think we need it in this. So I need to come up with a little wait for data. What do they say about response space? Time takes a center frame plus the response space, interbyte spaces, start bit, stop bit, break field. Use a break detection threshold of 11 dominant. There was something that had all these timings written down as equations. Frame length. T header nominal, break field. What is all this stuff? Hold on, let's see if we've got this in the other programs. Yeah, Ruxpin. When I was like real little, I was like a toddler, my folks for one Christmas got me Hey Buddy. Hey Buddy, hey Buddy. Da 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 da. Which is basically like an absentee parenting tool, like here's your new friend. And apparently when I unwrapped it, I started crying and punching it like relentlessly. I don't know what that response was, but they were all like, what? And so I never had a My Buddy doll. But I did have a Teddy Ruxpin. My brother had a Teddy Ruxpin, I believe. Be cool to still have it, but then again, like when I was little, like school age, like grade school age, I came home one day and my brother was watching Puppet Master on, I think, a VHS. I don't know how he was able to rent that movie, but so I watched Puppet Master at an age that was a little bit too early to watch Puppet Master. That creeped me out. What's my glucose level doing? It's not really moving as fast as I'd like it to. Come on, glucose level. What's going on here? Hold on. I just need to see what... Well, it doesn't recommend any more insulin, so I'm going to leave it alone. We're going to let AAPS be in charge of this. I had the Hostess Munchkin doll set. They did nothing. I don't know what the... Munchkins... I do kind of remember Munchkins. So my Get Bits program relies on a library that we don't have. Bit start. Digital read of the RX pin stuck here until not timer check. Timer start U-bit times breakout. So we want a timer that is microbit times the breakout time, which is for us, we're given it these. So when that timer expires, 50 plus 12 microseconds. Instead, we're going to say, hold on one sec, I just got to think here. Because yeah, this relies on a different library. Unless, well, let me look at the other program and see what I did. Oh yeah, so the funny part is that the Linguistic stuff that I programmed, the one that we actually want is the tester, the one that says the Bluetooth low energy test, because like normal, you know, the way we normally do things here, the test ended up becoming the main program. Bluetooth low energy test main. It's not in the new ones. I don't think I moved it, so it's in the old ones. So that would be in the drive. This is all getting very complicated, which is why I didn't do any work on it between streams. And I probably should have. Oh, this is, yeah, that's right. Cancel. Where do I get it from? Quick access, that's right. See, that's the one that works. Merc wheel, and then can test shifter, Lin brute forcer. It wasn't, it's pedal scan, those are scans. I don't know how, wait, how did I upload those scans? Oh, this is the modern one. Oh, okay, this is the normal, this is the newer one. I need the one that's on the server. I need to go into the folder. We just need to do it this way. What? Where's my stream pro? Oh yeah, it's underscore. No, that one's not working. Okay. That's the one. Okay, Merc wheel. Oh wait, that's the wrong one. That's the wrong one. Hold on. Network. Nope, wrong one. You know. Probably not. No, that's not going to work. That's going to keep at the WinSCP like shares for my yeah, Teddy Ruxpin took cassette tapes. My file server is all messed up because I upgraded it a bunch and that changed things around, and then it got like a different IP address and all this stuff blew up. And Windows got really used to having that file server be in just the right place and for this computer to have a particular IP address, and all that stuff changed, and the WinSCP share stuck. To the point where I'm considering if I want to just wipe this computer and like start over with a new one, but we can't do that anytime soon because computers are terrible right now. But yeah, at some point I've got to redo my whole stream computer. The WinSCP shares are messed up. The data that we're trying to get to is on my file server, and my file server doesn't like this computer. It likes my desktop plenty, but it doesn't like this computer. So I'm trying to find it again and find out how to get into it again. And it's just a little thing until it works. But it seems to think that this computer is there, and it'll keep asking me, driver network connection on the circuit stream unavailable. Okay. Stream unlisted or listed. Oh, no, we're not. It's okay. That's okay. It's something with the WinSCP shares. I'll have to get into it on my own. Because, yeah, it's like visible here. Wow, it sees Octoprint. That's weird. Hey, KTR. Better get a real router so you can configure it before the ban takes effect. I like my router plenty. It's okay. It's an Asus. I think in the end, like, what I would try to do is make my own router. Rabaz did that, but he used some kind of shady hardware, shady Chinese hardware on his own. But he did build it all, and it seems to work really nicely. Oh, here it is. Project 192168. There we go. So Merc wheel. One thing I really need to do is fix these shares so that I have access and I'm able to write stuff to this, because I've got a desktop folder with like a year worth of project, and I really want to have the project on the NAS. I want to have it on something that can't be killed so easily. 68U, 68X still running strong. I mean, yeah, I already do have IP addresses assigned. It's going to get messy if something goes down because I'll have all the IP addresses assigned in the router. OpenWRT is awesome. I'll never go back to a dumb router. Moving from the credentials manager, browse to the UNC path of the NAS via UNC. It'll ask you to log in and it should be fine. It's the Windows SMP share though. I mean, I gotta just go back into the permissions and do all that stuff. Yeah, but there's something about the SMP share on the IP address. I don't know. I gotta sit down and do it myself. Let's just move on so I can actually get to the project. I'm not doing IT shit right now because right now I'm streaming, and if I update settings on things, sometimes they want you to restart the whole operation. It has the old IP address cached. I think this machine should be on a fixed IP. I'll have to check that. But I'm not doing IP stuff right now because that'll knock the whole network around, and the Asus router doesn't like the changes. It won't just like implement the change, it'll restart itself. The credential manager. Yeah, see, you're using like IT stuff because you're smarter than me, and I don't understand it. So I'm gonna push back because I don't understand what I'm reading. But this is probably exactly what I need to do. I will give you that. I just don't know what all that stuff is. Okay, Merc wheel. We're looking for. Oh, stream. Yeah, that's right. So project stream, Merc wheel. And this is these are all old and moldy, 2022, 2020. Just different experience. You know. Arduino, Bluetooth packet engine, Bluetooth engine test, because there's no final software. We got this to work once, and I didn't look back. I just kicked something and it crashed into me. Here we have a whole bunch of different programs. That was just a way to organize the whole thing. So in timing functions, we're going to have all of this other stuff that I'm sort of using in this part of the program. We got to either pull it out of this or not use this timer in particular and figure out a way that we're going to time our stuff. Because I've been using microsecond delays because this thing is only concerned with sending the LIN bus packet. I had to use more complicated timers in the main program because we were doing LIN bus and Bluetooth at the same time. So in the timing functions, oh my God, there's so much stuff. We're using Arduino timer.h. And then I had a bank of timers that would tell you if they're active. Oh boy. So timer start is not in here? What are you talking about? Timer start. What functions do I have? Oh, this is all the, oh, okay, that's that. Here's the timing functions. What the fuck? Set timer. That's all I have. Maybe I'm not using that in here. Timer underscore active. Interesting. Okay, where is that's receive, and then LIN bus is all the way over here. I assure you that these programs work. We got all this stuff working, right? It worked great. It was maybe a little bit slow on the uptake for the pedals, for the buttons rather, but it worked. What's going on here? Send the break, send the bits, timer start, U-bit times breakout. But I don't think timer start is a function, is it? Let's check Arduino. Let's just check Arduino.cc or something. Yeah, that's part of Arduino timer. Yeah, it's not, no, that's not a base function of Arduino. But I thought that was something that I made up. Yeah, it is. Ha! Time set equals micro, timeout, use seconds. Time set and time out, and then we do a timer check here. Okay, so this does not use the library. This just uses micros. Perfect. So we're taking those, we'll put them in, like here. I like to have the serial prints be the last thing in the program, so I can just scroll down to the bottom of the page if I want to change my serial print stuff, because those change often when you're like developing stuff. Cool, looks like Microsoft just revoked credentials from the devs of WireGuard, Veracrypt, and WinScribe. So I guess anyone who wants to see a VPN, or to use a VPN directly on Windows machine is still screwed. Oh boy, so I'm holding on to Windows 10 until I die. So no foreign routers, no VPNs. Where's the pushback against all this stuff, you know? When is enough enough? This is too spaced out. Doink. Okay, timer start is going to do the timer set, and I need those variables. So I need to see what those variables are in the old program. So time set, time out. Time, but. Man, this is a big program. This is a lot. This is all for Bluetooth too. Wheel out, wheel size, pedal size, light size. Those are all those timing settings. Time set and time out. Where the hell are those variables? I need to know what they are. Timing stuff. No. No, that's for the different, that complicated timing thing. Time out. Ah, floats. Okay. We will be taking those, putting those in here. Oh, I already have them. I already have them. Thanks for that info. Yeah, did you just set alight some IT departments with this information? Okay, so we have our variables in here, which will enable my functions to function. We start off and we call the address. And then once we call that address, we have this little break time. And once that break time expires, we need to do bit start, and that'll get us into a while loop while digital read of the RX pin. If the timer does not expire, if it does, return 0. Otherwise, we delay a half bit. We're in the middle of start bit, we return a 1. So bit start is what needs to send next. So we bit send, and then we bit start. Call address if bit start hold on, I gotta see what I'm doing here. This is sort of the old way that I used to receive the packets, so yeah, this is the one. Call address for if, so we're going to get all this stuff. And then we do checksum stuff. So read switch for I is equal to blah, 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 and so we're putting in head size. What? It's a headlight switch. Iterate on our head size and then headlight of something. Of I get bits, delay microseconds, else return. I guess that's how we do that. Delay microseconds, blah, blah, blah. When we go through in the packet on its size, else return, read switch. So do I need to note that we have a packet or not? I'm just trying to get this straight. Like if I iterate through this every single time, well, basically once that's done, it'll return. Sorry, I'm just thinking about how this thing functions going forward. Okay, so this is handled getting all the bits, and it does it one bit at a time until the thing is done. Once it's done, what do we do? I think we want to serial print stuff. So when read switch, we maybe have a switch read variable. If bits start, else return. How do we reset that afterwards? Is there something I need to be doing? Hold on. It couldn't have been that rudimentary. For I is equal to wheel size, wheel ID, if bit start, otherwise return. But then I don't know if I got data or not. I need to know if I got data. I wish I had a ketchup packet emote. I spent enough time in coding streams that it would be a regular pull. Where would you get that from? Who would have a ketchup packet? There has to be one. I could, you know, I could give it to you here and do a BTTV. Do we like the one that's spilling? Gaussian wave? Gaussian wave? What are people doing on Twitch? Boo ketchup? You get what you get. We'll do mayo packet. Weird. Okay. Yeah, why not? Oh, I'm not logged in. Hold on. Not logged in. Need to give you the ketchup packet or the mayo packet. Authorize. And then we'll put this on, not my personal channel. That'll propagate eventually. I don't know when it does. Takes a minute. Okay, anyway, so yeah, I'm doing a lot. I'm trying to think about a lot that's going on right now. It seems like we didn't even check to see that we would finish getting the packet. We just kind of put the whole microcontroller into getting the packet and then we're done. And I guess that's how we're going to do it. Because like these 4 things will fail. But in that sense, I guess what I can do is I can serial print the... yeah, it seems like I've already got this test in mind. One vote for KEKW, OM, and SAG. SAG, maybe, I don't know. KEKW, I appreciate it enough, but I don't want it like being used all over the place, so I haven't bothered to add that one in. Let's see. Serial.print actually, we should just print out the packet, and then I'll have, at the end of it, I'll just have because the checksum will be the last thing in there. Kexage. I do need to go top from bottom and redo some of the visuals on this stream. We reset these windows so they look a little bit more diegetic, and I don't know, I could probably think of a different overlay. Maybe at some point I'll get inspiration, but yeah, these tech streams are tough because for a while, like, anyone else who worked on electronics was wearing a lab coat, and it's like, I'm not going to put on a lab coat to do this. You know, people were making their own sets and stuff. They had lab coats, and they would always have like a certain way of doing things, and you have to have like a resistor as one of your emotes, and it's always like MS Paint quality. So I decided to switch it up a little bit, and I went with sort of everything's yellow on the emotes, right? It's all yellow, and I'm going to do a chip design. And then I discovered, well after I had decided to make things the Google emote blob yellow, so that way I could steal the faces off of the Google blob emotes and put them on my own little chip, because you have to have a chip. You have to have some kind of an electronic component if you're doing electronics on a Twitch stream. But then I discovered the Fry Electronics mascot is a yellow chip, and this is some kind of a horrific eldritch beast. Nowadays, this would be brain rot. This may have fed into some of the algorithms that create the Italian brain rot that we are all so familiar with. But the Fry's Electronics logo is this little hand-drawn thing. Lucky for me, the pandemic destroyed Fry's Electronics. They are no longer, oh my God, the horror, the absolute horror of it all. So my particular design of the yellow chip is different because it was not inspired by this. But that looks a whole lot like my emotes. $2.99 DVD copy plus. Horrifying. But it's like this little hand-drawn thing, and mine's a little different than that. Well, they're not, you know, they're not media design people. They're computer salesmen. So there's not a whole lot of artistry going into that. Let's see. How do we print the packet in the old Lin stuff? Oh, I'm writing the wrong thing. Bluetooth engine test. Uh-oh. Let's just steal that. We won't be doing that anyway. Okay, so outside of this loop, we supposedly have gotten all of our data, and this is where we print it out. This has been reliable enough for me to use, right? It's just weird that I didn't have something that says, hey, we got a packet, but I guess no matter what, we're going to get data back, and then we need to check it against the checksum. So we calculate our own checksum using not wheel addy. Now, do I do wheel P? And yeah, I think I do, because this wheel with parity and headlights with parity. Headlight switch parity. Headlight switch not parity is 2, and the wheel's 1C. But if we're feeding it into the checksum thing, we're going to feed it in with that. And then our stuff is wheel. What is that for checksum? Bit start, get bits, checksum. Oh, and I need to make it checksum too. Address, data, number of entries. Address, data. In our case, this would be headlight. And then head size. You're supposed to make these variables so that you don't have to cross-reference them constantly. A smart person would have done that. I did not. Where am I? Head size. Packet. Has it not come through yet? Global cybermongers. Are they starting the process of splitting us up into nation states that are headed by oligarchs? Hey, there's a packet. Oh, but it shows up as mayo packet on here. Well, over here it's a packet of mayo. See, there it is. And the dog's barking at the door. All right, so this will print out their checksum. We want to print out our checksum as well as the packet. So we're going to start off. What are we doing? 4I is equal to? Yeah, we're going to do a for loop. 4 int I is equal to 0. These are such fast microcontrollers that I'm not really concerned with making these bitwise operators and stuff. But typically I will do like bit math in order to do these functions. And that way they're that much faster. But in this case, it's really splitting hairs. I should use the bit publisher in order to do that, because when it prints the address, it's just going to show up as the number 2. And we're just going to be printing it over and over again. We don't need all the niceties. I'm just going to do it very rudimentarily. And actually, this would be this function down here. Print bits, UNAT beats. So print bits, addy. Okay. So, just like that. Then maybe put a wall in between it. Print bits prints it with a 0, and it's just a little check loop. Pizza tastes like roasted campfire wieners. I approve. What are you talking about? Where's that coming from? It'll be there next time, and I'll use it. Yeah, I can hit refresh maybe, and it'll come up. Oh yeah, that just wiped my whole chat. Okay, never mind. Chat hide. Chat come back. Oh no, that's a different command. I need chat cache. Chunk. You guys have been blown up. I just vaporized my own chat. So I actually just want UNAT arsum equal to checksum 2 of all that stuff, and then I want to print the bits of arsum. Awesome. I could do something at the end here where it says if it's a match or not, but maybe we won't do that. So we print our address that we're sending to. That's going to be the same thing every time. It's just I'm setting this up so that I can iterate other stuff, right? You didn't vaporize me. Let's just see if the emote came through. Didn't work. Shit. It'll eventually propagate through all the different things. Actually, do any of those work? Do any of the BTTVs work in Social Stream Blade? Maybe they don't. They might not. I may have to configure something to get that to work. So we put that thing up with all of its walls, and then the very last part is the checksum, and then we just simply say ours, and then we'll print our sum, and then we want to end the line. So each line will be a different packet. It'll be the one that we receive from the headlight switch, and we'll have everything represented in hex. Oh, or 1s and 0s, actually. Yeah. 0 print bit read of beats. Yeah, okay, so it's going to be all ones and zeros. This is going to be a lot of ones and zeros. That's probably why. Wait, how do I get it to print both digits when it's printing in hex? It's a printf, isn't it? So maybe I need printf of... Arduino has this trouble with its serial monitor that it doesn't print the leading Fs of numbers, the leading zeros. And there was a way that we got around it with like a printf. There was sprintf, but that was not a function that Arduino uses. Yeah, printf. Hours, minutes, seconds. Let's do, zeros, hex. This computer's a little slow. I don't know what's going on. Maybe it's just the browser. You tried, yeah. If the incoming byte is less than 10, print 0. If byte is less than 10, print hex, void, print hex, uint 8t, hexes, if hexes is less than or equal to, or no, just less than 10, or 0x 10. Serial print 0, 0. Serial print hexes. Hexes. Hex. Else. Serial print hexes. Hex. I fixed it. I fixed the Arduino. So instead of bits, we're printing the hex. Although later I'll probably want to swap that to print it in bits so that I can see the ones and the zeros changing, so I know where to pull the data. But in this case, we'll just print them all as hexes and just have a big hex readout. Are you admitting to being called a serial killer? Slayer of grains. Where were we? Where were we? Where were we working? We were up here. Here we go. So serial print. So print hex, Addy. Serial print a wall. So that's do wall, and then we do serial print prompt James.exe hex. What was it doing? Print hex of headlight of I. So it'll go through, that'll print all the addresses with walls in between them. That's not with wall. The chemicals between us. Lying in this bed. Oh man, don't get me started on the modern rock. I used to listen to the modern rock radio station a lot, and I sort of phonetically memorized everything. So wall, and then it'll do, the checksum will be the last thing, and then it'll say ours, and then it'll print our checksum calculation, which should look like the previous. So the two sides of that hours should have the same address. And then print hex arson. So arson comes in as the checksum of the headlights with a parity. You calculate the checksum with the parity for Lin 2.0. For 1.0, you don't use that. So I would just zero out the address, and then this would give us the hex, or the calculation. Oh, we don't need comma hex on the end of that. That would have been a huge disaster. Everything would have gone wrong and exploded, and there would be fires, and then I would actually get viewers because it would be something exciting happening for once. This should do everything we want it to do. This should definitely do our homework. So we're not making the packet yet. We're not sending the packet yet. The serial prints I've put inside of the read function, which I could take these out. I probably should do that. Take all of this out and just have it do. But then it'll print if it doesn't receive. If it receives, it does this, else it returns. I need like a flag that sets whether or not we receive data, and I'll probably have to figure that out on my own, because for some reason today, I mean, like, geez, I'm getting advice about how to do IT stuff, and like we're talking about doing packets, and I'm talking about how I made my emotes. This is like ADHD central right now. So I am clearly not remembering everything that I need to be doing right now, and I'm not thinking clearly enough that I can build this into sort of a larger function-based program that'll help me make things like it in the future. I am just going forward and trying to make something do before the stream ends. So read switch, I'll need to implement some system where it sets a got data flag. Yeah, ooh, squirrel. Control S. Okay, one last thing to check is that are we printing to serial or are we printing to stuff? I forget. I forgore. We're doing serial prints, basic serial prints. Those go through the UART to USB, and they do not go through to LIN-bus. The LIN-bus TX and RX we're not trusting to a UART. And there's a long story behind that, and I feel like I'm the only person on the internet who had this problem. I should probably write this stuff down more in something more than just my stupid, Discord. I should probably have like a GitHub page for this, because what we experienced is that the UART inside of at least some of the Arduinos, and I'm not sure if we can gain control of it over the other ones, it's not able to do that LIN-bus wake up packet thing, because it has to send a little what is it called? The sync bit or whatever in between serial sends. So if I send, and I saw this online, I saw somebody said serial print 0x55. That won't work because there's going to be a little break in there. It's going to send a 1 or whatever, a 0 and a 1. It's going to break up that wait time, the wake up thing. So yeah, okay, anyway. We have to do this using bit banging methods. The thing is, though, this is nice and easy because we can get just like a function. We can get a library. There we go. We can get a library that'll speak CAN bus. So the CAN bus stuff can be as simple as serial printing with us. All we're going to be doing is polling our two LIN-bus devices and then shooting out a couple CAN bus packets. So we'll put that on like a scheduler or something, or maybe we can have a call and response from CAN bus. The CAN bus master can say, hey, I need to figure out what the statuses of these buttons are. And then these two will send like a couple packets, probably one packet actually, because it's just buttons over here. We don't have, oh no, we have one analog, but that means it can probably be one single CAN bus packet, because we'll have, this is only like a couple bytes, or maybe 1 byte, that's 1 byte. So that'll be 1 byte, and then a bunch of switches will be another byte, and then these will be another byte or 2, and that'll be it. The thing is, like in the real car, in the Mercedes, this wheel actually tells the master controller what version it is, what features it has. So you really can, within the same model year, swap the steering wheel for another steering wheel. And I actually did this on my car, my BMW. The E39 has a very thin wheel. I've got it sitting behind me. It's an M wheel from an E39, and I swapped it with an M wheel from an E46. E46, thicker wheel, a little bit more modern. It really updated the look of the front of that car. And it made it nice to drive. All right, Poopsie Doodle, thanks for popping in. Hey, I appreciate you guys in chat today. You guys are very active, and it's actually getting me to learn again how to ignore chat, because I don't mean to ignore you guys. I can keep up with chat, but when we do programming and stuff like that, it gets a little confusing to have chat running around fast. Over the past couple months, things have been kind of quiet here, and so I've been unlearning how to ignore chat and let them talk, let them do their thing, and get stuff done. I used to be a titan. I used to be a titan of this kind of stuff, because I'd have chat going and then I'd have burn the subs turn on. All this stuff is literally, I built it to distract me. Like, that's the purpose of these things. You know, and then the fart box goes off and all that stuff. I used to be able to ignore the best of them. I'm relearning it. So I think we have a cromulent program. Luckily for us, the headlight packet is the exact size of the wheel packet. I don't know how they pulled that one off. How do they, it's so much data. But anyway, we should now be able to load this into the Arduino, have it talk to the headlight, which we know that part works, and see what the data coming back is versus what we're calculating a checksum as. And hopefully there's not too many little things in between. So what I'll do is I'll turn on the scope here, and that should turn on very quickly. The way I refer to Arduinos, it does kind of seem that way, huh? It's just this little guy that's supposed to do the stuff that you program it to do. Hey man, learn a new move. It's called blow up a 3-volt device with your 5 volts. And then it goes, and then it goes out and it blows up the thing, and you go, all right, good job. And then you throw away a $20 microcontroller and you got to get another one. They you know, that is kind of an apt, that works. You can squeeze that into the analogy. The scope turns on very quickly, I might add. Very, very quickly. I don't know what Rigel was thinking. I think it's these Android devices that just don't turn on very quickly. Because for somebody that's used to using a scope, this is like unacceptable. Why did that happen? That was weird. Stop it. I guess it's still loading. All right, scale it up channel 1, turn on the scope. Oop, gotta blip it. Blip it. There we go. This is the best feature of these Android scopes. Doesn't want to stop. Can't stop, won't stop. This is the best feature of the Rigel scope. This thing has gotten a lot cheaper. I should not have bought it when I bought it. I bought it for like $1,000. $1,000. It's like $400 now. Anyway, yeah, I got hosed. But whatever, we're gonna try to ignore that. With how frugal I am about everything, buying eBay parts and stuff, that was a major blow. But it had the exact feature that I needed, which is the ability to have high FPS scope capture on OBS. And it turns out that I can pull it in as a web page. There's an intranet site that you can go to, and it has the scope on it, and all the touch controls are just mouse controls. Thousands of dollars is the life savings I don't have. Yeah, the thousands of dollars is something that I do not possess. All right, so let's upload code. So when I power this thing up, I'm gonna hit both of these, and then I'm gonna plug it in, let go of reset, then let go of program. There will be no signals here. Well, I haven't given it 12 volts yet either, so let's turn on 12 volts. Boop. I got 12 volts, 20 milliamps being consumed. Go over to here. We don't have any serials open, so I can hit upload and it's going to compile and see if I forgot any semicolons anywhere. Did I forget a semicolon? So right now we are just testing against our own microcontroller to see if we are calculating the checksum properly. This is kind of an important thing. It helps a whole lot to do this kind of thing because sometimes the way that bit math goes down in a microcontroller can change between microcontrollers. I've never seen somebody get this happy for a voltage analyzer. Listen, I tried to plug in all of the other Rigel scope features of my old one, the 1054, and everybody, oh, there's an Ethernet plug on the back. You can plug into that. no, if you plug in the Ethernet on that old scope, it doesn't give you something this fast. So it was having the ability to have this as like an internet site is amazing. Yeah. What'd I do? Too many initializers. What? UN8T backlight 2. aka unsigned character 2. What? What? Wait, what? Huh? What the? Huh? What? It had no problems with this before. Do I just need to do unsigned char? Or back size, backlight? Oh, 3. Yeah, okay. They're funny numbers because that checksum is on it. I didn't look at chat for that answer. It's not because no. It's not because I'm on the spectrum. I don't think I am anyway. I haven't had a doctor evaluate that, and I kind of don't. It's because if you have a problem and something solves a problem, it's exciting to talk about the thing that solves the problem, right? Come on. The fear of sincerity is so rampant on the internet, and I'm here to get rid of that. I'm here to get you out of that habit of not being sincere about anything. Sincerity is the spice of life. All right, so supposedly that went in to our micro, but I'm not seeing anything on the LIN bus. Oh yeah, until I open the serial port. Port COM3, open it up and bada COM3 is open, but nothing is happening. Oh, there's some. So we are not calling the address. Yeah, that's not calling the right address. Why aren't we calling the right address? We are just not communicating. What did I forget to do? Read switch, call address, Addy. Call address, break send, delay microseconds, send 55. We can see that right there. Bit send Addy. Oh, whoops. Let's do maybe up here. We can set Addy is equal to Willow. Well, actually on read switch, we'll do Addy is equal to. Addy is equal to. If we do, wait a minute, so when we read it, are we doing the bit shifts and everything? When we send the address? Bit send of address. So we're not doing the shifting that we do in the other program, and we're not calculating the parity. So we need to send wheelp. Not wheelp. We need to send send Holtzluf. So Addy is equal to Holtzluf. Wheelp, gotta go. Okay, so we call Addy now, and we can change that if we want to. Addy is a global variable, and I don't know why I did it the way I did it, but I guess that's fine. Read switch is a specific program to the switch, so I mean, I could just have it print hex headlights, but probably need some of those. Don't we all? Okay, so let's put that back up in, and some of this stuff is maybe not the most efficient way of doing things. I could probably, because it's read switch, so specifically I want to be reading the wheel switch, so I can make that specific to it. Although I could also alter that function to be more universal. And that way I could call, read device switch, and it would do what I want it to do. passing in the things that I needed to. That would make it a little bit more transferable between projects. Yeah, I should probably do that. I should probably do that. Oh, error opening COM3. Whoopsie poopsie. Let's do this. Put it into program mode. There we go. Upload. That's becoming like an automatic switch thingy that I'm doing to set this thing up into programming mode. So we should probably get all of our data back, and then we'll get a huge amount of serial prints once this thing starts rolling. Then in the call address function, I can actually have it set the flag. I could, hey, if it gets data, it'll set that thing. Yeah, maybe I should do that. What was that? Somehow the program ran once and it sent all that data out. Interesting. All right, so if I open up Serial, there we go. Why is it counting? I mean, our calculation is correct. Look at that. So from 0043 to FD45, all the while, our checksums are properly calculating. And then if I hit a button, you can see it change over there. BCBD, BCBD. 42 is the parity including address. And then 00 is that leading bit that I don't think, yeah. 7FB are the different things here. CBD, say less. Say less, fam. CBT, say more. Cool. Okay, so yeah, we're getting proper data out of this thing. Thanks to our efforts in getting it to properly read the wheel, we have been able to get it to read this switch because they're the same type of data and the same packet size. So it's been much easier to implement one with the other. Wait, why is that one stuck at 4F now? I guess it's always 4F. Wait, but we saw it changing before. It went to 4D. BCBD, so that's the second one. That one changes there, and there's another one there. And then the knob does just that one spot. Why is the other one changing then? Cover it over. Are we doing like ambient light sensing or anything? No. It's a shame this thing doesn't do ambient light sensing, because then I could incorporate that into the setup. D, E, F, F. 7C and BC, wait. D, E, F, and then that one changes that bit over there. That's kind of an odd place to put it. I guess they're not just next to each other. So there's probably like different modes and stuff that we could do. 7 CDC, the Timu Rock Band. So we can just take that byte, the 00 to FD. Why was that other one changing though? 4F was doing something. You guys saw it. You saw it. I'm not the only one. I'm just wondering if it's like my ambient light level sense, or if it's timed since it turned on. Looks like a hex editor force scan for my Ford F-150 is a lot like this. Yeah, so this is LinBus specific, and we're just printing it in hex. We're checking to see that our checksum calculation matches the checksum calculations of the headlight switch. Time since last meow. Meow! I added mayonnaise, by the way. We have a mayonnaise packet of mode. This is a momentous occasion. Beautiful. It doesn't go into the BTTV stuff, but... So yeah, what we've done is we've taken a headlight switch from BMW F10 series, speaking of F150, F10 series BMW, and we've hooked it up to the LIN bus, and we've brute forced into the address, which is 2, hex 2 with a parity bit on it, and then it responds with a packet that's the same size as the steering wheel packet that describes the position of all of its stuff, including the analog slider, the headlight switch position, and the fog light control. I don't have the extra whistles and bells because this is 20 bucks, so you know, we got the basic one, it's fine. I would love to have all of the features, so there would be another thing here and another button, but because we know how to interpret the wheel packets, we're able to interpret the switch packets. I'm actually kind of glad that I couldn't find the analog one, the one that plugs into the weird circuit board. I couldn't find it. What's going on, Flatulent Gonad? Are you streaming right now, like as we're talking, or did you end your stream? But yeah, this is the old headlight switch, and it had a similar switch on the end that was analog, and I lost it. I don't know where it is. And it really, really bugged me too, because that thing was on the desk for years. But anyway, in light of not finding it, I tried to find... Oh, what happened here? What happened? In light of not finding it, I tried to obtain one, and I couldn't find it. Well, hold on. I bought myself another one, and that fixed all of my problems. Oh, that shifted over. There we go. Now we're replying. I went on eBay and I discovered that these were only 20 bucks and that they're digital. There's only 3 pins on the back. So I was like, oh, wait a minute. This can do more adventures in LIN bus. So I did kind of a Hail Mary, and it turns out we needed exactly, we can do exactly what it calls for. You ended to eat cake. There was a funk noise. The PVC, the fum. So my debate was, hey, can we actually calculate a cromulent checksum that's going to interact with the LIN bus properly? Because I found, yeah, no, there's been times that Flatulent's been in my chat and he was streaming at the same time, and it's like, what? Wait a minute, pay attention to your stream. But anyway, we got all the data we want, right? And now we know that we can communicate with it. I found somebody was messing with a BMW water pump. And these blogs are always so cavalier about getting these things to respond to signals. I am shocked that we were able to get into this thing, right? And communicate with it. I'm utterly shocked. And these blog writers are like, yeah, so I just like got the address and the... Do you know how cool that is? So anyway, we brute forced, we know that the wheel or the buttons do one thing. The pump that somebody hacked into, their BMW water pump, it's like an electric pump of some kind. Oil pump, maybe? I don't know. But what they were able to get is if they pulled one address in the way that we're doing it, they get data back. And that data back represents the speed of the pump, temperature, a couple other things. I don't know what the others are. Probably like identification stuff. On the address that's next to the address that they pulled, they were able to send out data. And sending out the data got them a change in control, like a change in speed. And it was 2. So what we want to do now, in the silly little thing that we're doing here, I'm going to comment out all of these prints. Let's see, hold on. Or should I do... We can just keep that print. We don't need the checksum checker, but we do need this. Well, actually, we can change. We're going to change that into our own thing. So now we make the packet. So we're going to check one address over. So I need to call address. But I think I need like the full call address with the parity calculation. Let me get the parity calculation from wherever we had it last. It was that program that I just had open. I'll close this. Get this out of here. Yeah, this is complicated. I don't know if it's a vacuum pump. I forget what it was. I have the web page. I think I linked it in my stream project section. Let me see if I can find it. I'm hiccuping. Oh yeah, I need to do the end cards so that I'm streaming tomorrow. Hopefully we can put this thing to bed. I mean, what we're doing with it is totally fascinating, but I've had too many streams with it. Too many streams looking at the same thing, and it's so complicated that nobody really knows what the hell I'm talking about when I'm working on it. Let's go to pet stuff and see the picture that somebody... Oh, Mayor's posted something with one of our horses. Where's the horse? Horsey. Look at the horse. Okay. Stop looking at the horse. Okay. Where am I? Stream projects. Horse, Hans. Here it is. So what were they... People keep asking what they had hacked into. CWA 400, Lin example. Python file. There's your Python, by the way. I'm showing chat their Python. That doesn't sound right. Requesting and sending data with Peerberg CWA 400 water pump over LIN bus. So you get the RPM, water velocity, I guess, and then the temperature. Whereas when you're sending, this one's 25, they send on the next address for the TX. So you send RPM, 0, and then a checksum. So we're going to try that. No, it's parcel tongue is what they refer to for Python. So first we're going to make the packet, then we're going to send the packet. I think we should just do make packet. Yep, rotations per minute, RPM. We'll do this every round. We're just going to very rudimentarily do this. So we're calling the address that we've set before on the global because we read the switch. So we're just going to use Addy in this case. So we're going to actually no, we're not calling the address Addy. Why is this locking up when I'm scrolling? Something is like. I think this computer is like on dire straits right now, and I just haven't noticed. Hold on. No, that's smooth. Maybe Arduino is. This computer has been powered on for like a week, so I probably need to like reboot it when we're done. It's going to use some forbidden memory addresses, and everything's going to go crashing down. Do I have a serial port open? No. Yeah, it's really frustrating when stuff works like this. It gets really distracting. Define... And actually, I don't know what that address is, so we probably need the thing from the other program that calculates the parity. What was that? No, it's on the desktop. Hold on. Damn it. Work wheel, Lin bus, forcer, sender, we want forcer. Waiting. The program is so bad on this Arduino IDE. It takes a while to boot up new Windows. I don't know. I have so many weird libraries installed. I probably should wipe everything and start over. It should be any second now. It should open. This is the one that I want. Don't save that. Why isn't it opening? Try again. Open. Root forcer. Bud. Hello? Oh, did it pop under? Yeah, it did. Oh, it's been there the whole time. You're the problem. I'm being gaslit by my own programs. Okay. So what we want is this stuff right here. Parity. Doot, doot, doot. Copy that. And then down here, we want void paritize, and then uint 8t parity parameter. No, that's a stupid variable name. Par. So we pass par into this one, and then we take, actually, wait, we want uint 8t adder address, and then the pair, wait a minute, no. That is the address. No. So clear bits, and then set parity, and then return par. And then to clear the bits, we do the bit shifting from over here. We're bit shift. Just in case I pass something in that already had the parity calculated, I want to clear those bits out so that we don't accidentally double up on the parity calc. Are there more advanced ways to do this? Oh yeah, absolutely. Are we going to? No. And these all need to be changed to par. Why is this keyboard so small? I cannot reach the insert button so often. The iterating through addresses is why I want to be doing this. Okay, odds and evens, blah, 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 and then we return the parity. Okay. And then I should probably change how the other parts of the program are operating so they use paritize. But in our case, we're just going to we're going to send on 03, we're going to send the thing. So in this case, we can send HD without parity, put it in the right section here. Define headlight, send headlight TX 3. Theoretically, if we send it the packet backlight with all the right stuff calculated, we should be able to send it call address. Well, first of all, this is making my head spin. How's the CAN addresses doing? They're great. They look a lot like Linbus because they're still doing Linbus stuff. Parameterize headlight switch like that. ADDI is equal to the parameterization of headlight switch. So then we start our frame. Get data back, calculate the checksum. We're printing the whole address out. And with that, it's going to have its own checksum. We don't need to worry about that. We're just looking at what came back. So then we make the packet that we're going to send. And so what do I want to make that out of? Okay, hold on. I'm getting there. Backlight. That should be a capital. 3 positions in backlight. So backlight of 0 is equal to headlight of, where was it again? I don't have those serial prints anymore. Oh wait, we've got it just sitting right in front of us. Of 0, 1, 2, 3, 4, 5, 6, 7. No, not 6. 0, 1, 2, 3, 4, 5, 6. Yeah. And the first one's just the address. So we're there. Right of 6. Just for funsies. That way we're pooping the right thing on the right stuff. Backlight of 1. FF. And then backlight of 2. 2 is equal to checksum 2. Okay, we're almost there. Checksum 2 of parity, including checksum of the address. So I need paraterize the. Well, I need to do that anyway. I need to call the address. I need to paraterize it. So I need headlight TX address. Programming with functions. So up here, I need to make my own ADDI. ADDI to headlight TX. ADDI is equal to the parameterization, rather. Parameterize headlight TX, and that's what ADDI is going to equal. So then that creates that variable. Backlight address of 0 is the headlight read that we just had. That's a blank. And then this one checksum 2 of ADDI, and then backlight, and then back size. There. Whew. A few more projects and Bother's going to decode a whole Beamer's communication. I know, seriously. These are the things they don't want you to know about this stuff, but it's actually really easy to sit around here and pluck little addresses out of the ether and sort of make functions that do the things that they don't want you to do. They want me to spend thousands of dollars. If it helps, my space sim is not converging either. Well, the cool thing about this system is that it's going to be configurable. We're going to be able to reconfigure for all kinds of different games with this thing. I'm hoping, assuming that everything's going to be fast enough. I think the Raspberry Pi CAN bus should be fast enough. It's Node-RED might slow things down a little bit, but yeah. So then we call the address. We make the packet, and then I guess we're making and calling in the same thing, but that's fine. Although I could actually just leave it at that, because we've got our checksum, we've got our stuff in there. Yeah, let's do make packet, and then void set stuff. So then we're going to set stuff afterwards. And when we're setting stuff, when we're we're going to do, what are we doing? We're doing call address ADDI, global address. And then once we're done, we're going to break. So call address sends the break, sends the bits, sends the address with a parity. Then we're out of that. Once we're out of that, I need to break send. And then I need to send backlight. Get bits, checksum, timer start. What am I doing here? It's bit send, right? Yeah, bit send, and then bit send backlight of 0. Well, for int I is equal to 0. What was that loop again? I've got that somewhere else. Common loop that I'm using in all this stuff. Back size. I is equal to 0, I plus plus, print hex. I don't need to print hex, I need to send. So what was that again? It was bit send headlight of I. And we don't need the serial print in there. We're just going to look at it on the scope. I'm doing this as rudimentarily as possible. Maybe do your main controls direct. All the buttons for lights and stuff don't matter if there's a slight delay. We're going to see if I get a delay first, and then I'll have to either split systems off or take all of the irrelevant stuff out. I want to start with just the Hail Mary and giving everything to CAN bus, because I think CAN bus can handle it. It should be fast enough. It's just I don't know if Node-RED on CAN bus can handle it. It should be fast enough. You know, I think doing this is like the way that I like to do things, and I'm just kind of like full sending it. It's sort of the streamery, let's not be careful and engineer this. Let's, you know, run head first into the wall. Node-RED is fast if it's not too busy, but if it's managing like 16 devices, it's going to be kind of busy. The time in between doing this stuff, it's going to get back the packet. I think it needs to wait just a minute. I haven't tested the limits yet, and that's what we're going to do eventually. Because I've seen, you know, like big industrial robots use CAN bus, and all kinds of, like, the 3D printer is sending all kinds of data back and forth from accelerometers and stuff, and it's not doing all that much. So I think I should be good with CAN bus on this whole system. What my vision, chat, my vision is to have a whole bunch of peanuts sitting in a row on my desk. That would be really cool. I mean, a whole bunch of devices will be on the same CAN bus. So we're doing Lin stuff right now. That's going to roll into a device that's going to speak CAN bus to a larger network. And all of those CAN bus things will all be just pooping data out into the ether. When they do that, Node-RED will be listening in on that ether, and it'll receive all of those packets. And then my Node-RED routing will determine what packets are then sent back out onto the same bus. And on the same bus, I can have OpenFFB and a bunch of HID devices plugged into a USB hub that will then communicate all of my button presses or whatever else. Nose-RED. Yeah, Nose-RED will be indeed sniffing, and all the peanuts on the packet. Need to create a Chin bus to do CAN and a Lin bus for everything else. Lin bus is too slow. We ran into problems with all the analog stuff that I was doing where I hit a button and it's like button. And you're like, wait, why is there a delay? Just because Lin bus having like multiple things on there is slow. So in this case, we've got 2 Lin bus devices. If we can just have those on their own 2 device bus, that'll be fine. And then also with this thing, I can have it say, oh, there's no change, let's just hang out. And it maybe could put the devices to sleep at some point too. So, okay, so let's put a delay in between sniffing the packet and retransmitting the packet. Since we're the only thing on the bus, we don't really need to worry about much. We'll just read the switch, and then I'll delay swook del delay. I'm gonna give that one 15 milliseconds. That's like an eternity to these devices, but we're going to have to zoom out on the scope in order to see that communication happening. And we'll see whether or not, it'll be really cool if this thing turns on with its backlight. But let's try it. Time for back shots, chat. Let's go. Oh no, I didn't do this. Close this. Close this. Put this into a mode. What did he say? Did he just say something about... What did he say about... Herk. Okay, so that's dead. We are compiling. CAN and Lin on the same bus. I mean, the Lin bus communications would be just noise on a differential line. So it's possible that you could do that. It's possible. It would just be like, oh, there's some noise. Ah, of course, my variable name. That's always what it is. Parameter as eyes. Yes, I intentionally made a confusing Why is this like, oh, it's so distracting. I'm trying to like smoothly scroll through this thing and it's like getting caught up. Where's prioritize? Paraterize. All right, let's go find where I've called that. Once I do that, we should have... I am going to predict that this thing works perfectly the first time. Bit send. Print serial. Whatever's being printed is going to be very confusing and weird. Chaos in the streets, cats and dogs living together. Where else am I calling this? Well, I guess I'll find out. We'll let it scan on its own. Yeah, this whole program needs like a lot of organization, but the functions that I wrote were good enough that we're able to kind of like get from one thing to the other on this, and it's a little bit more exciting than writing an entire program for each function. It's nice that I've got my sends and receives. I could probably make them a little bit more smooth, a little streamlined, functioning in kind of the same way. So you do stuff the same way each time. I've seen there's a couple Linbus libraries, but none of them quite did things the way I wanted it to. Yeah, there it is. There it is. That's the one that I was looking for. Spelling them both wrong each time. Paratize, not paraterize. Hopefully our timings are okay too on these sends. Bit send should hopefully deal with that. We'll see. If there's something messed up, it should be pretty plainly visible. And this thing is in program mode. Paratize, what have you done? What have I done? How many times did I call this program? Jeez, okay, upload. Come on. It has to be the only... I only called it 3 times. We could look on the Lin table too to see what the parity is actually supposed to be, but I went through the trouble of programming that little parity calculator. I want to use it. I know sometimes you, as Gonad says, you need to utter the correct number of curses in order to get something to happen. What? It does not like the return. The return of the R, of the power par. Let's see. Paratize. UN8T par. Return par. Return to par. The phrase that makes the Arduino IDE function is, why is it so fucking complicated? And you have to utter it at least 3 times. What am I doing wrong with this, with the return here? Oh, because I called it void. Paraterize the address, poop it back out like that. And that shifts out the parity, recalculates it, sets the bit rights, and then shoots it back out. It's like Claude where you have a regex check for profanity. I should probably steal that regex. Watch your profanity. Because we need to do at least a minimal amount of filtering on Burn the Subs to try to make sure that, you know, there's not another come in Santa's beard incident. Or was it coming? I think it was the verb. For those of you that don't know, who haven't been around for 500 years, because the old board filled up during the pandemic. I had a board on my wall that burnt with a laser Oh, whoops. I forgot to write this. I forgot to write the program. Anyway, I had a thing on my wall that burnt the usernames of subscribers onto itself. And there were some pretty raunchy names. It was pretty crazy. Didn't I write this? Why am I writing it into the wrong thing? Did I write it into the wrong? No, that's the right thing. Where did I end up writing that? Oh, this is okay. I wrote it in the wrong line. I put it into print serial. I was wondering why there was stuff in print serial. Okay, that corrected that problem. My YouTube name's like that. It's half the fun of having your name. Yeah, but so like you got to think about it like in the game sense, right? Like why can't we just not interact with the cultists at the beginning of Far Cry and the game would just end there? Or what if they had cell phones in this movie? We have to do our job as the antagonist to the funny thing that's happening. So the funny thing is that we have this beautiful engineered piece of technology that's been sort of cobbled together and very carefully built in order to interact with Twitch in a novel way and really give the users the ability to receive thanks for their monetary contribution to my channel. And it does it in an elegant way. It uses a blue laser, which is a really visual and exciting way to etch things, and it scribes it. It doesn't just rasterize it, right? It scribes it. Beautiful motion. It does it onto this piece of wood, this warm-looking, just sort of fine thing. It's, you know, you see etched wood is something you see in like a trophy hall or, you know, some beautiful place with dark stains. And it is burning a contributor's name, Poop Nuggets 65, right? Like that's the joke. It's highbrow poop jokes, and so we need to set ourselves up so that there's a payoff for that. And setting ourselves up to the payoff, I could make it just write fuck over and over again, or you know, say fuck username. You know what? Do that. We go, look, this has to be classy. And then Twitch makes it not classy. That's the cool part. So, Celia Russell, thank you for subscribing for 101 months, 101. Hell yeah. Thank you so much, Celia. You'll notice things have changed. I feel a little bit more awake because I trimmed the beard and I got my hair cut. Good stuff. Whoa, what just happened? Celia Russell gifting to Leb TV Live for 123. Wait, Celia has 101. Leb has 123. Crazy. How about let it grab all the names but show them on screen for 5 seconds with a stop button? I'm scheming about doing that. Since Burn the Subs can be drawn into Node-RED now, I can have that system in Node-RED. And so if I don't smack a big stop button or like a smart button, one of those staples things, it'll go into the board, but it'll have to be something that I have to like reach out and grab and hit. Because there's a couple that are actually off limits, like especially getting into certain realms of humor that I just don't want to propagate. Yeah, well, not a yes, no. I would rather have it on a no. It's just a no. And if I screw up, I screw up. That was stupid button. Yeah, like a don't cook button. That's the kind of stuff that I can spool up in like an afternoon with the Node-RED setup. Okay, so expected a thingy before a thingy. What are we thingying? This seems pretty well contained. Thingy. Oh, parentheses. Bit send, headlight of eye. That should work. Bits send? Is it bits send or is it bit send? Bits, I suppose. That should be its own thing. Headlight of eye shouldn't need a semicolon in there, because it's doing just what this does. Oh. There you go. No, no, that's not right. Does that get one? No, it doesn't. Int of I is equal to 0, semicolon, I is less than backside, semicolon, I plus plus, parentheses, thingy, bracket, bit send, headlight of I. It's the same thing as this, but this one wasn't flagged. I don't get it. I don't get it. There. It's not flagged because you're printing. What? No, it's doing the exact same thing. It's print hex, headlight of I. That's the statement. Yeah, weird. Unique. What's there's? I don't see it. I don't see it. Is there some other like bracket mess up somewhere? Doesn't look like it. Semicolon, semicolon. That's its own little thing with semicolons. There's no semicolon on that, but my other loops are like that. Like that one's not flagged. Check again. Yeah, it's fine. Colon instead of semicolon. 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 Bits send or bit send. Bits send. Okay. Bits send. So I got that right. Headlight of I of ohm. I don't. What the? Bit send. That's my own way of sending. Where is that? It's down here. Print hex, paraterize, timer start, checksum 2, get bits, bit start. Where's bit send? It's in here somewhere. Print bits, print hex, paraterize. Where the wait a minute, hold on. This program works, I swear. There it is. Bit send, write the TX pin low, delay for a microbit, go through and iterate through the bits that have been sent to this. It's a UNAT stuff, and we iterate through stuff, setting the highs and lows, and then we delay before getting out. So that's what's essentially communicating to things. So headlight, headlight, semicolon, and then that loop is exactly like this loop. I is equal to 0, I is less than size, I plus plus, and then no semicolon here. Why did it run into this? This is fuck, what's going on? Delete, delete, return, format it back. Just in case there's something like in here that's not supposed to be. I'm just gonna run it again. Go. I sent you my bits. Please respond. Int I is equal to 0. I is less than or equal to back size, or less than back size, I plus plus. Is it going to choke up on that again? It's compiling a core. All right, now it's going through. And now it's looking for the RP2040, and it wrote it. Okay, so it was like a rogue error. All right, so now when I open up the serial console, we're going to get 2 packets. Okay, we only got 1. Bud, you want to wake up? Wake me up. Wake me up inside. Save me. It's not responding when we're pulling that other address. It may need to just be reset. Here, I'm going to bounce 12 volts. Doink, doink. Is it replying? Well, we don't get any serial prints out of this, so. It doesn't respond when we do this. What the heck? All right, let's stop and let's take a look at what we got. So there's no reply for, well, 3, okay, so it's not replying for our call. And then our thing over here, whoops, hold on. That's us communicating with it. So we don't receive a packet yet. We haven't had the thing reply, so our variable's not getting set. Getting denial mogged? But then we call for this thing's address and it's not replying to its own address. But I changed one of the parameters on it and it may not be sending it the right parity bits. Oh, did we do the edits in this one so that the parity would go through properly? Yeah, I think we did that. Yeah, because not 1, 3, 4, 5, and then it's regular 0, 1, 2, 4. And I rewrote that so that they all line up and everything, and it looks nice. So we're sending it in par. Oh, that's what it is. Working on the wrong variable. So we're sending back out par, and that gets written to parity instead of just directly editing it. That way it's more of a universal function. I just forgot to change all of the whatever they are. Double press, lift 1. Scope goes blank. Oh, hit run. Yeah, scope goes blank, and then we can upload to the device with the correct variables. I'm passing in par, not addy. The way this was written, it had addy, but then I made addy into a universal variable, a global variable. So I needed to get away from that variable, and I forgot to change it on bitwrite. But the reason it didn't catch that is because it was bitwriting to addy, which is now a global function. So, though in that sense, it probably should have calculated it correctly. Well, whatever. What's going on here? Oh, COM3 is still open. Yeah, like I tried to isolate it and make just that program calculate the parity if something passed into it, but I forgot to change 2 of the variables, and it was editing a global variable, so everything is chaos. It's chaos. Now we should be good, and hopefully we get to see this thing responding, and maybe once it responds properly, maybe it lights up. That'd be kind of cool. Okay, so there we go. We've written. Now I open the serial port, and that'll start our program. Oh, and our serial prints are kind of ugly. But now we're at least getting the replies we need to get, seeing as the data packets are a little bit more fleshed out. Wake me up. Now I'm doing it. I hate it when Rabaz does the Linkin Park goofy wake me up inside thing. I hate it. I hate it. I've heard it too much. But when he, like, mentally he gets bored and then that pops into his head and he starts going, wake me up. No, it doesn't look like we're controlling backlight, huh? The wake me up inside goofy version is a national treasure. It's not Linkin Park. Who's that? Evanescence? I think it's Evanescence. All right, so we are not lighting up. So that address did not work. Ah, yes, Evan of Essence. Might as well have it just print out the whole packet, huh? Why is this so slow? It's getting slower. Arduino's getting slower. I don't know what to do. Oh, my whole computer is starting to get a little weird. It can't only be OBS Studio that's killing it. Firefox. Yeah, a little bit. Browser page? Oh yeah, having that up I guess is doing a little bit. I need OBS, but the Arduino is the one that's acting weird, so I don't know why. Lots of Firefox. I don't know. See those delays and how it's like locking up? Right there, right there, right there. Don't like it. Yeah, I'll need to make it print out statuses in a better way, but for now, let's get rid of any of the prints. Well, I need something going on to tell me that it's functioning, so let's do this. There. Okay, so now we know what we're sending. Let's try sending it in that second bit instead of the first. So second verse, same as the first. So what we'll do is we will take 0, no wait. Yeah, we're gonna do 1 and 0 swap. Let's try that. And then we'll try address 0 and see if that changes. Windows Update has code that counts the amount of keystrokes and mouse clicks to tell if you're most productive to download a 5 GB update. That may be what it's doing. I don't know if there's like a Windows 10 update. Yeah, it looks to see if you're active and then it decides to hamstring you and make your computer not work in just a way to kind of gaslight you so that if you tell your friends, they think you're a crazy person. Okay, new program. There's that. And no backlighting. Nope, no back shots today. Sorry, everybody. So we got to try some other addresses then. Is our send changing? I think so. Let's make it print out the send. Oh, my Amazon lady thought I was talking to it. How quaint. No, bitprint or something? Print, and then this one is instead, it's backlight. And then back size. Okay, that'll give us our full printout, and let's put these back to 0 and 1. And then our headlight TX is gonna change to 0. Yeah, it's a shame that didn't do anything. Now, we can also build this into iterate through everything. I can have it iterate through all of the different things to try to set, low and high backlight. And I can even solder a wire to the LEDs that would tell us whether or not we found the address. That would be kind of cool to do. Wait. Oop. If I get it just in time, that should do. Scanning for RP2040. There we go. Cool, we found it. Oh, I'm glad to have learned that process of throwing code at this thing over and over again. Okay, and then no backlight. Is that going in the right order? I think so, because we're byte 0 is what we're, yeah. And actually, we should put the address ahead of that. That's here. So print hex of Addy, actually, we're doing that again. And we send, yeah, and then we do all that stuff. Okay, so that didn't work. Let's do the swap of these two. So that's 0, this one's 1. Close the serial, hit upload, put us in programming mode, ready to go. Yeah, so I may have to iterate because it might be like on the higher numbers might be where the control is instead of being directly adjacent. The theory was that it was directly adjacent because I found somebody writing about hacking into a BMW water pump and the TX and the RX addresses were right next to each other. I refuse to close serials. We must have serial everywhere. We still have 01 to try too. Okay. Wait, what is 80FF? Oh, I forgot to put a wall in between it. Yeah, so now we're editing that, and we should have a good checksum on it. But no backlights. The pursuit of backshots is a noble one. And so we need to have a wall after the address. I would do these on 2 lines, but then it would be TXRX, 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 and that tends to get a little weird looking. It's hard to look at. It's seizure inducing. There we go. Okay. So that's that corrected. We've tried those addresses. So let's change this back to 1 and 0. And then we change our address up here to 1. Send that. I could also build something so that if it sees me hit the fog lamp button, it'll flip the 2 bits. That would maybe be a good thing to set in. Oh yeah, doot. What an idea, yeah. I wanted to make it all on the headlight thing, but then I also thought about programming it and I got tired, so I didn't do it, but having the controls on the thing I'm testing is kind of funny. Scanning for RP2040. Wrote 142K? We've been busy. This is a big program. No COM3. What did I do to get COM3 working again? Hit reset on this. What? Unplug. Replug. There you go. C1. Oh, I guess that's with parity calculated. There's that, and I don't get any backlight. Aw. Come on, man. I wanted to just magically start working. No, I didn't find the light switch. Chester, you see, people are like, why does it bother explain all this stuff? There's like a history to it, and Chester's coming in with that deep ball knowledge of bother. That sounded wrong. Why do we call it ball knowledge? The previous setup, or what I had for many, many years, I had a light switch that plugs into this thing, this big computer in the E46, and that controls all these MOSFETs and stuff that turn on and off all the lights. And you know, we featured this on the channel and looked through it and see how it works. And the headlight switch would have been really cool. We could have just gotten a couple of like the voltage levels and the whatever else gets flipped, in order to send out CAN bus messages, which this thing probably spoke, but you know, I could incorporate that into the simulator. I lost it. I don't know where it is. I looked everywhere. And then I looked everywhere again. And I really, really looked everywhere. I tried to have that old headlight switch. And then I got to thinking, and I got to searching. Did I scratch this already? Oh, that is a scratch, isn't it? Wonder how that happened. I guess it's fine. It's fine. It'll get scratched anyway. But yeah, so then I went on eBay and I looked up headlight switches to try to replace it. It was about 30 bucks because they're getting kind of rare. This was also 27 bucks. And this is an F10. It's the same generation as the rest of the car stuff. So now I have communication with a LIN bus device because everything's going LIN bus instead of having all of those controls on it. This thing can speak to a LIN bus network, and the bus master can decide whether or not it wants to turn on the headlights. And so we're implementing that right now. We discovered that its address is 02. So at 02 with parity calculated, that comes through as 42. Is this not doing anything? Yeah, there we go. You can see the checksum changes and that last value changes, and my computer is starting to struggle for some reason. I don't know what's going on there. I'm not dropping frames. It's the Arduino itself that's having trouble. I only dropped 250 frames this stream, okay? But yeah, as I change these, our hex readout is changing as well. I know it's basketball. I know the origin. At this point, I bet you know more about BMW communication than half of the EEs that work on this stuff. Maybe. Implementing, like doing the systems engineering is always like, you have to know everything. So we've transmitted to the address 01. And what was our bit order? I mean, this is getting caught up on things that were invented in 2006. So this like struggle that this computer's doing right now, and it might just be Arduino, is really getting to me. I don't know if we can do this much longer. So 012, so 102, and we'll just see if that other address happens to be. And we know our checksums are good. We're calculating the same checksum that this thing is sending. So serial port is closed. Ringo is kill. There, only one Arduino window open. And then put this thing into program mode. Having the scope readout on that helps. Upload. This computer needs to get restarted before tomorrow's stream. Now it needs to check if your subscriptions are active. What? What do you mean? Huh? What does? What did I say? Oh, this needs to check with BMW corporate to see if you've properly signed up for good for headlights. You have not paid for headlights this month. Therefore, you do not get headlights. Only those who pay deserve to see. Serial... Oh, wait, no. Oh, no, I did the... Yeah, serial monitor. Bring. No backlights. Come on, man. Come on, man. Okay, well, so I need to now devise a way to punch in headlights or backlights onto increasing addresses. So as we iterate through, I need it to hit it with that packet. But then if it's doing that every 30 milliseconds, I can't see whether or not it's actually affecting any change in backlighting because I don't really know the level of backlight on this. I think what I want to do is I want to make this button push us over to the next TXRX, to the next plus. And I needed to do it only once, so I think I need to set up like a latching thing. Because if you hold the button down, I don't want it to, you know, iterate through 5,000 addresses. That would maybe mean a timeout. Or a periodic check of the button status. No, but then that would require, okay, I got to think about this. I think we got somewhere today. Not very far, but we did get somewhere. My programs are getting more and more organized and easy to, like, you know, do weird stuff. Oh, the excited jellyfish and the less excited jellyfish. This is a jellyfish that's sort of jumping out of the water because it's the fog lights. That turns it on and off, fog lights, and then high beams are, you know, an exploding jellyfish is just your parking lights, and this is, why is it down? Those should be up. Those should be going up. Wait, where is, oh no, this is brights. That's, okay. Oh no, brights are on the stalk. That's right, brights are on the stalk. And on the stalk, the symbol is the jellyfish going up, because they're not just brights, they're high beams. Right. All right, so anyway, we're getting data out of this thing. We're getting data out of the switch itself. I just need to jiggle around the wires on the signals that we're sending back, and hopefully we can find, through chance, we can find what packet that is. So tomorrow we're going to do iterations. We're going to iterate through the values, and we'll see whether or not stuff changes. And I'm going to gamify that. I'm going to turn that into something where we're actively participating in it, because otherwise it's going to be very dry and boring. I could set up this all completely automated, but when you do set up stuff like that that's automated, you need to know that you're sending it the proper stuff. And we could still be off on like a timing. I might not be sending the packet fast enough. 30 milliseconds, 15 milliseconds, I think is fine though. So we'll take a look at that tomorrow. We're going to work on that and we'll make progress, I hope. This is a lot of progress right here, because these programs are going to form the basis of what does the CAN bus stuff. CAN bus, you just throw a library on there and you give it its own like UART, and it'll just do CAN bus with that. So, okay, thank you for joining me. I really appreciate you guys being here. I hit reset on that so it stops. Yeah, luckily we were able to like program, implement. I like streams like that. I like to keep them like that because that's more exciting than just like writing and troubleshooting a program the whole time. But I hope to keep it less than completely dry and boring. But obviously numbers are looking at me in the face. But I guess everybody's probably online right now. Should we see who's around? I don't want to throw you guys at too loud of a channel. People complain. Ow, when I did that, I stretched a muscle. Why did I do that? Weird. No, nobody's online. One of Adam's moderators, Paleontologizing, is on. He's a pretty interesting guy. You guys should check him out. Actually, let's raid. Yeah, let's raid Paleontologizing. Raid Paleontologizing. I'm gonna spell this wrong. Invalid username. No, I can't spell. Raid. I've already cut and pasted the name. I've already cut and pasted the name. Thank you for joining me. I'm going to be back. Here. Quick end card. You guys can freeze frame if you need to. 20 hours, 27 minutes, 12 seconds, 55 cheeseburgers, 55 hot dogs, 55. All right. And stop